现在时间12点55分，我们在5分钟之后要开始第2阶段。We will start the session 2 in 5 minutes. 另外，今天一样，因为防疫的关系，请大家务必要全程戴口罩。For combating COVID-19, please wear the mask all the time. Thank you.
好了，开场。
好，时间刚好是1点整，再次的欢迎大家来参加第2阶段的这个研讨会。Good afternoon, ladies and gentlemen. Welcome back to the section 2. In this section, we will focus on topic of a secure economy, international trend, short speech. 第2场的论坛主题是循环经济国际趋势产业短讲。那么这个阶段的主持人是王宏博博士。我们欢迎 the moderator 王宏博博士 Professor， 欢迎。
Thank you. Good afternoon. This section we have 4 presentations. Yes, 4 presentations. And start with related to the research to commercialization by Dr. Gao from the Arizona State University. And then we have 2 presentations by by videos, presentations. And I apologize, we have 5. And the one, Mr. Chu, is from Penotech, and he will get some of the global marketing, sales, and financials related to the circular, green, sustainable. And finally, in the final presentations, we have from the Mr. Zhang Liangyi, he will get us some of the viewpoint from the NGOs regarding to the some of the circular economics. Okay, then we start with Mr. Gao, Dr. Gao, please.
Right. Afternoon, everyone. Thank you for having me. My name is Andrew Kao. Right now, I'm a research affiliate at IETA. So at IETA, we try to achieve like as a platform to bring all the experts from industry, government, and academic to solve the complex social issues such as climate change or circular economy, etc. So today, I'm going to talk about the NSF Engineering Research Center Program, or ERC, and see what kind of experience that we can apply within the Taiwan context. Oh, okay, all right. So if time allows, I'm going to briefly touch about the ERC program. And if we still have additional time, we can talk about the newest announcement of the Generation 4 ERC program and see if there's any opportunity for international collaboration. Okay. All right, so the whole ERC program started back around late 1970s and early 1980s. At the time, the US car manufacturer was losing competitive advantage to Japanese companies such as Toyota or Honda, and as well as the Germany's companies. So the government asked the U.S. National Academies to see what can be done. And around 1984, they published a National Academies report saying that the reason that the U.S. manufacturing industry is losing its global market share is because there's a huge disconnect between academic and industry. So first, for academic, for faculty member at the university, at the time, the whole research focus is about blue sky research. It's about driven by scientific discovery, curiosity. There's no practical application in mind. So we think about X-ray or penicillin. Those are great technology innovation that has no practical application before the scientists even start the research, which is still true to this day. But it's not wrong, but it's not the right solution to the many societal problems we face today, such as energy policy. And the second issue related to the disconnect is the engineer that graduate from those universities. So the story is that engineer from Japanese university, it took about 4 to 5 years to become fully functional employee working as an engineer in the automotive factory. Whereas in the US, it took about 6 to 9 years. It took a lot of extended in-house training to become a capable workforce. So it's almost identical to the problem we face today in Taiwan, where we don't have enough engineer working on other like solar panel or offshore wind turbine project factory. So to that end, they proposed a new program. Right, so you can see that a lot of graduate students, I heard a couple, maybe 10 or 15 years back, all the undergraduate or graduate students, they say that the job I got, well, the education I received when I was in university has nothing to do with what I'm doing right now. So it requires a lot of internal training by the private industry or companies. Yeah, so So they propose a new program, the ERC model, to bridge the gap between university to private industry. And it will serve as a bridge between the two sectors. Now, so in that report, they say the three major components for ERC has to be first, research. You need to shift from fundamental research to problem-driven or more applied research that has you can apply to society or manufacturing industry specifically. And education, the new curriculum, you need to train engineering students. You need to prepare them to become more prepared as a engineer or workforce. And the third one would be industry buy-in. So a lot of private companies that will need to become members or become affiliated with those research center. They will provide their own engineer research personnel and give workshop or just brief introduction or even internship opportunity to the students. And those three arms were working together. Those are the main focus for the ERC. And the requirement based on those three requirements. So for the research team working in the ERC, you have to be more than just one single discipline. You have to be, so a computer science has to affiliate with working with scientists from other university or other department, such as electronic engineering or environmental engineering. And education, meaning that those, they don't confer degrees, but they do provide undergraduate or graduate level classes to the university student. And the third one, the industry. Usually you need to have about a dozen private industry, preferably in manufacturing sector, that will pay a member fees and indicate that they will have interest to buy the technology once it got invented from the ERC program. Those are from the NSF program website. So what's an ERC? Well, basically ERC is just an R&D center located in just one university. Have a solid affiliation with other university in the US. The focus is, remember, the focus is try to enhance the US company economic competitiveness. And most of the researcher personnel is university professors, faculty members. Okay, so on 1985, they announced the first generation ERC. These are huge program. It's a block grant. At the time, it represents about 20% of the whole NSF research funding budget. It moved from single principal investigator, just one university professor writing a research proposal to the National Science Foundation to just, we give you a 10 years dedication and give you in theory, it's 6 million per year, and we give you for 10 years. So it's 60 million. It's a huge investment from the NSF. And also, the private industry is going to match those budget funding. And so far, as of right now, there's more than about 70 engineering centers. So they define by different generations. Right now, about 3 generations. Each generation very differently, just depending on the emerging technology and technological focus. Okay, so you can see that the location, they try to spread evenly across the US. And because of the IETA, I just highlight the ERCs that are working on the energy and environmental related centers. Those are the generations, the second generation. And these are the third one. You can see that the energy sustainability or environment has always been the engineering focus or the main technological area for the past 30 years. And most of those centers are still, right now, is still operating in different forms. So the ERC program considered, well, it's a flagship program for NSF. It's a highly successful. The intellectual property and the spin-off or economic impact has always considered a successful program. These are just the latest number. You can see for most of the research in the audience, you can see that those are the end of year report we collected. So invention, patent, license, spin-off. And those are for the research faculty member, how many journal articles, conference proceeding, those things. And the workshop or educational curriculum. And these are the education, the new education output by the ERC. But these are the most important ones. ERC produces a lot of capable STEM workforce compared to the conventional US universities. And these are, well, most of the people know that it takes a long time for new technology from research all the way to commercialization. So the first presentation by Professor Zhang about microalgae, you remember that it took him about 12 years to become like just an idea to a proof of concept to practical application. And depending, because the ERC program is so successful, on top you can see that it started to shift the whole dynamic of science policy, how government fund scientific research from single private investigator project to the block fund center-based program. So it established different center programs. So the IUCRC is another center-based program. It's smaller in scale, but it's more applied. And the Science and Technology Center is also another popular center program funded by the NSF. These are just the latest report. You can see that a lot of US R&D right now is all center-based. And the blue one indicates the center program funded by NSF. The TRL meaning that how mature is the technology that can be ready applied to the industry or to the manufacturing process. And as you can see, the NSF program is still dealing with a relatively fundamental or rudimentary technology. It's not that ready to be applied by the to push to the market. And I'm going to talk a little bit about the unique feature about ERC is that each ERC has about 10 years lifespan, meaning that the NSF, once they award the program to a university, they're going to commit about only 10 years of funding, which is a lot. But after 10 years, NSF going to cut their funding and hope that that center can self-sustain itself. And the majority of funding going to come from the industry member, the private firm. That's the idea when they first established. And these are the latest estimates. So out of all the graduated after 10 years after they graduated, 39 of them still operating in the US university, while others maybe just disband or just completely finish or shut down. So after 30 years of research, a lot of people are trying to evaluate what's the benefit of ERC program, which by all metrics is a success, but there are some downsides. So the first one is that once the NSF, after 10 years, once the government start funding the university, you can see for the research, you can see that the center research shift from fundamental to more applied or risk-averse R&D. And the faculty incentive, it becomes low incentive for the faculty member to participate in the ERC because they don't consider the research they are doing in the ERC going to help them get tenure. And also the intellectual property issue is very difficult. And once the NSF withdraw the funding, usually the private firm also will decrease their funding to the program, to the center. Yeah, for the industry, for private firm, most of the research coming from the center, usually still, most of the research produced by the center is not applicable to their own product immediately. And it requires them a very high fee charge. So, and education, well, for the master level or PhD level student, most of the concern, well, the idea is that when you work at the ERC, once you graduate, you have already a social connection or human capital to work at private industry. However, most of the students, they fear that once they dedicate their 5 years or 10 years in a single project, their job prospect, meaning that you can only select just 1 or 2 private companies to work with. And you become almost, the center almost become a employee, the training ground for the private company instead of higher education. Right. So, right. Although a lot of centers survive after NSF pull their funding, but they'll become less like an ERC, but more like a conventional research center. And for most of industry, the reason they try to affiliate or participate in the ERC is because they try to gain access to the faculty member for the researchers, meaning that we have a technology consultant for our own product. It's not about the technology or the licensing or the patent generated by the ERC. Okay, so for most of this, it's almost like a small case of market failure. You can see that the graduate student, once they graduate from the ERC, 60% of them working at the industry, that's all right, but only 10% of them working to the ERC member from those private companies. So from a company perspective, they pay budget or they pay resource to the engineering center, but only 1 in 10 of the students will come work for my company, whereas most of them will work at my competitor. So the incentive is not there. So it's difficult for them to continue their budget or their funding support for the program. Okay, all right, hold on. This one is I want to touch about the Boston Lab. Before, you can see that from the other government support, you can see the different technology area. You can see the energy, well, the majority of them is from NIH, so about healthcare and about computer science. Energy infrastructure stay the same. However, for the private industry, you can see that from 2012 and onwards, the investment continue to grow. So meaning that there's a lot of economic opportunity in the energy sectors. And this one is, the important thing is that for the graduate student from master level above, you can see that 42% or more than half the students are coming from foreign countries. We're talking about Chinese student, South Korea or Indian student. Even Taiwan students have about 11 students right now working at the ERC. And these are the 2017, the latest report. The National Times recommend US government to relax the requirement for the ERC and to allow for international collaboration. They tried, the original purpose is to help the US companies, but right now it's so successful, they try to open up for all the university around the world. Right, so those are the announcements for the fourth generation research center. And now the newest program is called Center to Center program, meaning that one ERC and can affiliate with the other research from abroad. So Chinese government, Ireland. And for faculty member interested in that, you can go to the NSF program or come talk to me. We can discuss details later after the presentation. Okay, with that, I'm gonna open up for the next presenter. Thank you.
If you have question or comment, maybe we can have that at the panel's discussion after the presentation. Okay, and the next presentation will be given by Mr. Jackson Chu. He has extensive experience in the global market sales, and today you want to give us some of the circular green, sustainable financial applications, please.
Hi, everyone. Thank you very much. On behalf of one of the organizer, Paneltech US, thank you for your attendance here. I'm going to spend next 15 minutes to share with the financial applications into the circular, sustainable, and green market. My name is Jackson, and right now is working for the Paneltech to structure the financial plan. And this slide shows the green bond market as a green project and green objectives. Objectives from the green society-wise is more or less is improving the climate change. How we improve the climate situation by implement the green projects into the building, into the alternative energy, or into the different approach to sustain the natural resources, and how we make the project available under this green bond. If we choose the project without proper evaluation and proper guideline and supervisory monitoring system, that project cannot be identified as a green project. Right now, I highlight a little bit about the pollution prevention and also the sustainable management into the social societies. And also, the most important is how we improve the climate change, the severe change right now we're facing. And of course, the circular economy is one of the major focus for the green project as well. And so the green project come back to the bond market. We create the bond since year 2007. So the green bond wise, you can consider as a climate bond. Also, you can consider as a project bond. How we based on this project in green economy, and then we can define as green bond. And after that, the people not satisfied with this approach, so we go to the sustainable approach. How we can make the world with more improvement into the resources and also into the living quality improvement. For example, say how we can increase the job opportunity, increase the continuous education to the people, and also how we keep our environment to be more participation by everyone in the world. So the market then create a sustainable bond. The market then create a sustainability bond, which is based on the green project and plus sustainable approach, and then comes to the sustainability bond. But this bond is not major exposure in the market so far, because they're going to use the principle of the bond to invest into a non-profitable approach, to provide education, to provide the food to the hungry people, or provide the cheap apartment for people as well. So those projects may not be able to generate the profit. And so we also call this bond into the social bond. So the market right now, you will see a lot of different variety of this approach, but basically every bond must based on the green approach, green project. And so how the people going to see how much effort have been done by the corporate or by the individual. So the corporate investor-wise or institutional investor-wise, if they own the green projects or they invest into the green bonds, they're going to benefit the CSR scoring and also ESG scoring. The ESG representing environmental social governance is more regulating into the corporate management, how they manage their business into more sustainable approach. And CSR is more responsibility, how we keep the business in green economy side. So overall, these two transition of the bond market, and then we want to merge together with the circular economy. How we make the circular economy into the variety of elements as our focus. Here we want to highlight the waste management. How we can make the waste and use the waste into the low carbon emission and also low usage of the new plastics material. So we can, based on the green approach, and then move to the sustainable, and then using biodegradable material, which we using from the waste of agriculture and plastics. So the people going to benefit the CSR and also enjoy the ESG achievement. So we can make a perfect circular economy and into improving our climate. So that's the element. We want to combine all these crucial elements into a new business model. And how we can make that, actually the Panatech can do that. Firstly, we take a plastic waste and also agricultural waste and making up into the material we're going to use to make a product. I want to highlight here for the plastic waste, actually we can use waste of waste. What does that mean, waste square? The waste of waste, that means the plastic recycle company use all the plastic waste to do the recycle usage. However, they can only use up to 15% or 20% of the plastic to be able to recycle. So remaining of the plastic going to be the garbage. We call the plastic garbage, which they cannot manage those plastic waste at all. And then our company owns the technology, and we can make up that waste of plastic waste into our material. And then the material going to do the products and then going to face the consumer, go through the global channels. And then give you some idea about our product approach and product applications. So our product including the biodegradable plastic bags, and also, of course, for biodegradable bottles as well. And we can also use for the construction material by combining the agricultural waste together with plastics waste. So those construction material into the floors, into the furnitures, or even we can use to the recycle way to reuse those material more than 5 times in the future. So current market-wise, if we buy a so-called the green floor material in the market, for example, if they can do the carbon emission reduction into, say, 100, and actually our product can do is into 22. So our product-wise approach using the agricultural plastics waste together, we can comparatively improve 78% carbon reduction from our peer group. And also we can apply into the clothes, how we can recycle the clothes into a new functional and a new biodegradable clothes or shoes. And that's our product application. So this is the perfect circular business, because you can see we do from the waste, we do the material, and then we create the consumer products and then sell into the global channels, and every citizen in the world, we're going to use these green products. And this is how we want to combine these 3 major engines, as green project is a must, and then sustainability is also our responsibility to help the world, help the weaker country to have their education or their living environment. And then we implement our circular business model into this bond market. So I'm going to show a little bit this 3 engine to remind you to take this as into the memory, and how we're going to introduce our approach for the bond market. So we'll explain what is circular sustainable green bond. This bond category is our innovation. So it's brand new in the market. So it's our honor to share with you. And second session, I'm going to explain a little bit how we use joint venture opportunity to work together with any investor have the interest into the green project. So let's come back to the green bond we design as a circular sustainable green bond. As a typically, we can help a country, or we can do a corporate, or even entrepreneurship, like even the foundation approach, because the sovereign definitely owns a lot of the waste, maybe from plastic, maybe from agriculture, or both. And corporate side, definitely, they may have their own products generate the waste. For example, the grocery shop. You can imagine grocery shop, they daily sell the plastic wrapping foods or plastic bags or even the bottles or that kind of plastic waste. Also, they're going to generate the waste by indirectly you cannot see as the juice. For example, the orange juice, apple juice, that they harvest those fruits and make the juice to the consumer. But what's the leftover from those trees? Trees are our target to use up as well. And of course, under this bond, there is a must who going to manage the green project is us, Penaltech. And so we can help to issue 5-year or 10-year in US dollar. Maybe we offer the fixed rate. And the right corner is what inside of the bond. The inside of the bond must have the green project. We're going to use this waste, reuse the waste, and repurpose the waste from the agriculture and plastics. And also we will approach with sustainable targets. So we can increase the local job opportunity. We can improve the education environment for them. And also we can generate good living support for those local people as well. And underlying business model, we apply the circular economy business model here. Because all the bonds need to pay the coupon for sure. And also we need to pay for the sustainable projects. Because a sustainable project is not the project can make money. So we're going to use this circular economy approach to generate the financial aids from our financial performance to support the sustainable projects. So which make more sense by not using the principle of the bond, by using our business performance into the investment. So final approach is we must achieve low carbon emission. That's the must. Also, we cut and reduce the usage of a new plastic material. And then we can do the waste recycle and repurpose the function of the waste into our product applications, into different end product to the customer and consumer market. And so the circular green economy here, you can imagine is much less financial burden because we can generate good financial performance by this arrangement under this bond. So if the government support this approach, we can use their waste for sure, and then we can build a factory or set up the production line onshore to increase the job opportunity, and we can exporting those products to global channels or sell into their domestic to their own citizen. And so that's the example. If the corporate do the issuer, for example, there's a high polluted approach, high-tech company, and all this computer, all these keyboards is made by plastics. And actually we can help them to recycle, to reuse, and also repurpose those plastic waste together with our technology we have and combine together with agricultural waste. And then we can transform those waste maybe into the construction material. That's how the benefit is going to help. This bond can help the corporate to manage their waste. The financial-wise, you can imagine, financial-wise is doing more charity approach things. So that can be the potential issue as well. So overall, this circular sustainable green bond, we target for a large scale of the issuance. example is like $1 billion or $5 billion, that kind of big projects. However, if the smaller scale of the investment interests want to come into the green project, also want to enjoy the circular economy business. And we explain a little bit joint venture investment. And joint venture investment wise is pretty much is for their community or city usage or corporate usage. And first, we must use their waste. The resources of the waste is the must. So we can use those trees, we can use the forest waste. For example, from Indonesia, you can expect a lot of the forest waste, or even from the palm trees or coconut trees. And even in Taiwan, we have a lot of the rice. So rice straw can be the resources for the agricultural waste. And also you cannot imagine, we can also use the shells. The oyster shells can be the resources for us to make the plastic bag to be biodegradable. So that's the technology we can implement into our business model. And plastic waste, including bottles, bags, also clothes. So the joint venture arrangement can be different approach, can be shareholding things, only put the money in without managing the project, or into the partnership things because they have their own production line or they have their own factory. They want to use our technology and apply into the green business, and together with our expertise in marketing to sell those green products into the market. So they can do partnership arrangement. So that's the joint venture we're talking about here, with a smaller scale of the capital investment, but they can still enjoy into this contribution to the green economy. And also, those projects definitely can be self-financed with the banks, with other financial institutions, or even we can issue a small size of a private placement bond into the market as well. So here is Paneltech. Paneltech, we can maximize our technology and also our channels. That means our business model is we see the demand first, together with our technology, and then in between we create the product into the market. That's the application we have. So before I finish my talk, I want to overview a little bit where is the global green bond market right now. The sovereign support, as I mentioned, the sovereign can be the issuer for the green bond. Yes, Germany did, France did it, and Netherlands actually did as well. So this morning, Netherlands is quite humble. The representative is very humble. They didn't mention. They were the first AAA country to issue the green bond in the world. Actually, they are the first guy using their government resources to issue the green bond to help the green project. They issued around 6 billion euro back to year 2018. And UK going to issue next year. And of course, we also have the supranational agency under the World Bank. They're using IFC as the issuer and also provide the financing into the green project. And Africa, you can imagine Africa Development Bank also participate into this kind of sponsorship for the green project. The CAF is actually from Latin America Development Bank. And also EIB, European Investment Bank, is one of the largest participation supranational agency. Right now they call themselves as climate bond or climate bank. And so their goal right now is to help worldwide green project owner to implement their project into different scale of the growth. So next year, we see from the article, the new issuance of the green bond we will see 1 trillion size. You know, this year, so far alone, is only 265 billion issue size. It's almost 4 times for the issuance next year. But we expect after our bonds, maybe the issuance size should hit 2 trillion. So this guy is a little bit agree with me. So the next year is 2 trillion size. However, this size is only weighting less than 2% of global bond market. So there's a lot of room to grow. It's a lot of opportunity for everyone to participate. Individual can buy green bond to help the green project indirectly. The corporate can issue the green bond or support the green projects by themselves. Also, they can invest into the green bond issued by other people. So that's the beauty. We access the financial market by issuing bond to tackle those financial support. So that's pretty much end up with my presentation. I repeat, these 3 engines is our expertise. We create this perfect circular economy into sustainable green bond. And thank you very much.
Thank you, Mr. Chow, regarding the green bond, green projects. Tell us how the money come from. Okay. Now, next 2 presentation will be given by the videos. So let's just start.
Good morning from Austin, Texas, to the 2020 International Conference for New Energy and the Circular Economy. I'd like to extend a special thanks to Panel Tech and their executive leadership team for the invitation and the opportunity to participate in today's conference. My name is Greg Peden. I'm a 30-year product and packaging industry executive. I'm an engineer by discipline, and I spent my first 9 years after college working for Compaq Computer Corporation, which was acquired by HP, and then Dell Computer Corporation. Over to work for packaging manufacturing companies immediately after that. I started in sales for a corrugated sheet plant, and then I joined another packaging manufacturer, which was North America's largest foam fabricator, Austin Foam Plastics. I started in the sales arena and then was promoted to vice president and general manager of the corrugated division. Following that, I was vice president of sales and strategic partnerships, cultivating relationships between not just customers in our team, but also our suppliers in our team to create incremental value for the long-term customer. Promoted to senior vice president of AFP's emerging business unit, which was the largest revenue generating business unit under their umbrella. And AFP was acquired by Sealed Air Corporation, which you may know. Sealed Air is the company that invented bubble wrap. I was promoted to Sealed Air's vice president of enterprise sales and commercial strategy. As we move into today's conversations, packaging is integral. Product and packaging development go hand in hand. 96% of all products manufactured globally end up in the packaging world. We focus on reduced cube initiatives, driving resource reduction, using less packaging materials, and increasing product density on a per pallet basis to drive reductions into our cost of goods. Optimizing design to do more with less really reveals how much true volume of packaging were associated with the products before these redesigns for cost optimizations began. An example is going to give me an opportunity to introduce similar challenges and how we address the opportunities and challenges in a sustainably focused circular economy. Today in the US and globally, sustainability lives in a much more visible position for every country, every community, and every company. We see how not investing impacts our climate, natural resources, waste, and pollution. Our single-use, throwaway culture challenges companies who must compete in the open market to make economic or ethical decisions with both the customer and shareholder in mind. Today, more than ever, we see signs of sustainability influences everywhere. In the United States, the EPA has published data generated by the American Chemistry Council. We see about 380 million tons of plastic produced annually. The country with the largest population, China, produced the largest quantity of plastic at nearly 60 million tons. That's followed by the United States with 38 million tons, Germany with about 14.5 million tons, and Brazil about 12 million tons. The actual recycling rates are not related to the actual production rates. Germany, Austria, South Korea, Wales, and Switzerland are the top 5 global recyclers on a per ton basis. I would bet that the size of these countries and the landfill utilization are the key influences in that status. In 2018, the US produced nearly 38 million tons of plastic. Only 12.2% was identified as municipal solid waste. Still, the amount of recycled plastics is relatively small, 3 million tons, or 8.5% of that total volume is being recycled. The recycling of some specific plastic containers is more significant. Your soda bottles, water bottles, and milk. The total amount of plastics combusted in municipal solid waste outlets was only 5.6 million tons, which is about 16.3% of all municipal solid waste used for combusting and actual energy recovery. In 2018, landfills received 27 million tons, or 18.5% of all plastic generated became municipal solid waste. Some of the most visible problems with plastic products and packaging is the pollution we all see in our daily lives. We see discarded single-use recycled plastics on the streets, in the parks, beaches, subways, and our waterways. It's really hard to miss. We see the growing visibility of plastic around our waterways, our lake, our ocean, wildlife, presenting harmful and vivid and impactful imagery. The average person takes responsibility and pride in recycling. However, they do not know how much of the plastic they clean, sort, and put in their bins never gets recycled. Recyclers state that economics outweigh ethics, saying it's much less expensive to put our collected for recycled plastics in our landfills than to sort them, truck them, and pay for someone to take them away to place in a responsible chain of recycling. Facilities are for profit. So they are separating the mixed plastics of all those plastics which generate value, water bottles, laundry detergent, bottles, and milk jugs, and sending the balance or the mixed plastics directly to a landfill or incinerator. As a packaging professional, I'm keenly aware of the sheer volume of packaging generated in the delivery of every single product from its point of origin to its point of consumption. Packaging plastics is the single largest business segment consuming our plastic resin. 42% of all global plastics converted end up in some form of packaging: film, foam, thermoform trays, bottles, jugs, caps, or bags, and the list goes on. What to reflect on is that packaging as a medium may be designed and specified for recycling. It's intended. However, plastic packaging typically is disposed of when the product is not. Still, I find it surprising that of the 146 million tons of plastic used in packaging production in 2015, 141 million tons of that was determined to end as waste. When we talk about the issues of carbon footprint, it's eye-opening. Plastic actually has a very large carbon footprint, but so do many alternatives to plastic. This is what makes replacing plastic a problem without a clear solution. But this is also what opens the door for innovating in the vein of a circular economy. Plastic is just a form of a fossil fuel. Your plastic water bottle, your grocery bag, your tray full of berries, they're manufactured from either oil or natural gas. It takes a significant amount of energy to make that happen. So the origin of the plastic carbon footprint begins to be measured at the wellhead and the pump, where it's pulled from the earth, then you can follow its journey to being converted into finished products and/or packaging. Every single stage of plastic production emits greenhouse gases, starting with the production of resin from petroleum, making products from resin, and the disposal or incineration of plastic at the end of the day. Plastic waste incineration versus recycling presents a significant threat to public health and the environment. Incineration precipitates into global warming, acidification, photochemical ozone, or smog formation, and the potential pollution and poisoning of humans, animal life, and the planet's ecosystem. Current and relevant innovations around recycling, sustainability, plastics, and some of the issues that reinforce the need for a meaningful conversation around a circular economy. My roles with Compaq and Dell in the late 80s and early 90s, we operated in a traditional linear economy. We focused on designing, sourcing, and building a product to meet the current and short-term needs of our immediate future. As champions of continuous improvement, we delivered improvements in technology, quality, overall product costs in the realm of that traditional linear economy. Simple innovations that may reduce the number of screws, which reduces the number of touches, the number of parts that went into a computer, yielded cost efficiency. Those were solutions to challenges. Today, we face a similar challenge. Thinkers, we must identify the challenge and actions necessary to evolve the legacy linear economy model of take, make, and dispose in order to progress into an impactful and efficient global circular economy. Deliberately re-engineering the circular economy to redesign that use of once sourced plastic to successfully be recovered, reprocessed, and/or repurposed. We must now intentionally promote a circular economy design and logistics for each component or material used in a product's manufacturing process, so it may be responsibly recovered, disassembled, separated for a planned integration into the reprocess and repurpose vein of a global circular economy. Can you imagine engineers and product development teams selecting a material for a circular economy versus a traditional linear economy? There's a genuine possibility that the best material selection includes qualifications of reuse or repurpose, recycling, and a long-term cost avoidance of raw materials. Companies can significantly reduce the material cost, sidestep the landfill, and share the metrics in a compelling story about this chain of custody, bolstering their profits, saving the earth and its natural resources, all while delivering a solution for an unmet need in an open circular economy. I'm suggesting that in this era of hyper-technology growth, supercomputing, and artificial intelligence, that we get back to the basics. We know our educators, institutions of higher learning, innovators, inventors, countries, and corporations recognize the value of critical thinking and collaboration. I think back about my boss at AFP and as a mentor, leading me and my executive leadership colleagues, that he hired us to think together, not alike. I can assure you, we all came from different backgrounds. We had different beliefs and different experiences. But when we focused on making decisions through collaboration, we are confident we delivered the absolute best overall decision each time. We are seeing progress in many areas, but we must leverage the shared public and private initiatives in a global capacity, thinking globally, but acting locally. Sustainability, pollution, greenhouse gases, and natural resources, they're real issues. We must come together to deliver sustainable development goals and objectives, then commit to legitimize and monetize a true global circular economy. Advocating collaboration around critical thinking, problem solving, development of initiatives and activities that incorporate public and private business and universities to deliberately drive innovation and evolution that serves our people, our communities, our countries, our economies, and our planet. We need the influences and commitments of many to aid in the shaping the evolution of product design, assembly, manufacturing, recovering and reprocessing materials like plastic to create a paradigm shift in a circular economy for our environment, world, and communities. We are realizing innovations that are green solutions, bio-based solutions, but through the lens of a global economy, we know that we must create solutions that support both economic impact and the vital environmental impact that must be delivered. I'm encouraging today's audience to make a commitment and pledge your support of these communities to innovate and collaborate. It will crystallize the adoption and the support of the global community in creating a thriving global circular economy and a better planet to pass on to future generations. Thank you all very much. Thank you again to Paneltech's executive leadership team. I hope my participation and observations were helpful, will precipitate change. Please enjoy the remainder of the conference. Thank you.
Good morning, good afternoon.
The next presentation will be given by Professor Fleming. He will also give us bio videos.
Good morning, good afternoon, good evening. This is Professor Rob Fleming here with a short presentation on the net zero first design process, a critical part of circular design. In 2005, a series of events occurred that radically and fundamentally reshaped our relationship to the natural world. And since then, we've seen time after time critical disasters that have wreaked unknown levels of havoc and environmental destruction. And we continue to see this today, and we project this into the future. We have a responsibility as design professionals and as engineers to take action. The circular economy is one of the ways that we can do that. And more specifically, I'm going to talk about net zero first design process, a pathway to get to net zero buildings. Now, net zero buildings generate as much energy as they consume, or in some cases, they could be a net positive building generating more energy than they consume. And this is really the wave of the future. This is where we're heading. Right now, these buildings look kind of ridiculous because solar panels themselves are not yet efficient enough to fit on the roof. So we have to make larger roofs than normal. However, these kind of buildings did not happen overnight and are not common. And my goal in this presentation and in general is to make net zero energy buildings a standard across not only the US, but the world. In order to do that, we're going to have to think differently. We cannot continue to make incremental improvements into a failed and flawed system for making buildings that have ultimately destroyed our environment. And so if we change the way we think, we'll change the way we design. This is a pyramid of innovation that I've developed to understand net zero first design in context. So at the bottom, if you know Maslow's hierarchy of needs, then you'll understand this. This works as layers. You've got to start with empathy. Your motivations have got to be critically developed. And then from there, you develop philosophies that are going to change the way you organize your thinking, frameworks to organize your thoughts, new design processes, which is what we're going to talk about today, and then ultimately getting to goals, strategies, tools, and outcomes, what most people focus on. And I'm going a lot deeper today to get to the roots and foundations of what we need to do. Empathy across space is pretty simple. In first world countries, we're polluting, and third world countries or developing countries are feeling the brunt of that development. They will be the ones to suffer the most first as we continue to destroy the planet. And furthermore, how do we begin to have empathy across time for people we never met, for future civilizations? The decisions that we make today have direct impact on the ability of future generations to have their quality of life met. I would argue that a lot of it is the difference between self-interest and empathy. And today we're going to focus on this side. We need to move to this. If you're in the US, you know that the last 4 years have all been focused on this, and look what we got. Nothing. And so now we need to move forward and think about an empathetic future that works for everyone. In order to do that, we need to go beyond the triple bottom line to develop the quadruple bottom line. We're going to think about ecological regeneration, economic viability, social equity, and then finally, and surprisingly, design excellence. Things have to be beautiful in order for them to persist and to be sustainable. Now, take a look at this diagram right here. This is a really critical part of the philosophy. In the traditional model of design, everything is about design excellence, placemaking, and social equity and economics and sustainable design factor, and I'm talking about more in the academic sense, factor in as subsidiary aspects of the architect's goal to make a statement. And so what we're going to do is take this and move it down here and make design excellence one of the 4 quadruple bottom line aspects of what I'm calling authentic sustainable design. So if you're doing a green building, great. If you want to save 10% energy, please go ahead and do that. I would appreciate it, but I am looking for net zero energy buildings that are authentic and have a real impact on our future. In order to do that, we have to think across disciplines. The engineers have to work with architects, have to work with landscape architects, and so on. And we have to think through multiple lenses. Yes, experience is important, but we've got to understand culture and equity. Systems integration, key, and finally, behaviors and performance. Can you be a holistic thinker? Can you look at the world through multiple lenses? So what if every design project met net zero performance goals? What if this was our code and our credo? Well, we're going to have to really change how we think, especially in design schools. For most architects, we tend to go right to dessert. What are the pretty pictures? And what we forget about is that we need to finish our plate. We need to eat our vegetables and eat our protein so that we can be healthy and now and into the future. And then only after we've done our due diligence that we have met our responsibilities and become healthy can we have the dessert. And so I'm going to talk about what this means in the studio. Basically, it does mean that we have to reach net zero energy design standards before making any kind of formalistic or aesthetically driven decisions. Yes, what I'm talking about here is fundamentally and radically changing the way we design. So here we go. So the current method of design is very, very, very linear. And sustainability is often tacked on at the end, at the last minute. So you'll see a lot of research, you'll see some design concepts, you'll see more design concepts, you'll see more design, you'll see more design, you'll see more design. But what about all of these other issues? Carbon footprint, especially considering the presentation we're doing today, doesn't really have a place in aesthetically driven formalistic architecture. In other words, this system doesn't allow for some of these more technical aspects to come in a very direct and intentional way. And I'm not saying that designers ignore these. I'm saying that they're not the priority. And what this presentation is about is changing our priorities away from, you know, solar power being added on at the end. We're going to throw some solar panels on the roof and call it a green building. I'm still happy with the 20 to 50% more efficient building. I'd be so glad to get those. Certainly want beautiful resolved buildings, but that is just what we have in the present. And I don't think it's going to get us over the finish line as a society. A nonlinear design method with sustainability priorities front loaded. A lot more research, especially climatic research, a lot of pre-planning, a lot of sustainable design is done before any drawings are made. Let's bring in our social equity discussion right from the very beginning. Let's go to preliminary design, passive design, active design, and use those to intentionally bring in aspects of design that have to be considered prior to what we might call the aesthetic design process. So ecological concerns, climate responsiveness, building envelope optimization, where a lot of the net zero energy aspects come in, has to be done early. We don't want to get to the end of a design project and then decide what materials and what envelope. And so what I would argue is that this is sort of the razor's edge. You've got to get to net zero energy performance and then go on and have your normal design process. Go ahead and have your pie, have your dessert. Try to fit in here now the carbon negative performance, which is a little bit different than net zero. Net zero energy is a one-to-one relationship. Carbon negative is a much broader, more holistic look at a circular economic model where we're not only looking at the energy of the building, we're looking at the transportation of the folks coming to the building, the energy sources, the carbon generated at the energy source, et cetera. You know, I have this here in the process because there's so much here already. But if we can get to this, it's not hard to get to a carbon negative performance project. And at the end, we get to a beautiful resolved design and we get to net zero energy maintained. And we have a new present civilization that's really exciting. So let's dig in a little deeper. the order in which we make decisions is critical. And I'm using a lot of food references here because we like to think about it as what we call an EUI countdown. So we talk about EUI being energy use intensity, which is sort of like miles per gallon for a car. And can we track as we move into the process getting to zero energy? And when we do that, now we have created a recipe for success that then can be built upon and innovated upon. This is the map of the process. I'm not going to go through the whole thing because it will drive you crazy. In fact, I'm going to go through it in another slide. But rest assured, what you see here, I just want to be really clear, is there is a hard line here. Net zero energy ready project. And we use ready because we don't know for sure how people are going to use their thermostat. So we're making decisions on HVAC and PV prior to the normal design resolution experience. And this is critical because the engineers now play a critical role in early design methodology. And that's not the case right now on many projects. Sure, there are exceptions to this, and probably at this conference, you're seeing lots of integrated design examples. Part of the secret of this is really delaying the complexity and trying to layer on top of each step more and more variables and more complexity, so that as we get to the end, the design resolution is sitting on a platform of strength and the number of complex decisions grows on a platform of certainty, which is kind of an interesting concept. So when I teach the studio, we really don't introduce many complex ideas in preliminary planning to kind of keep it simple. Now, we're using an emergent design model here where design ideas emerge from a design thinking triple diamond approach, and I'll explain what that means in a minute here. Let me just zoom in on this so you can kind of see what's happening. There we go. So what you're going to notice here really quickly is that the diagram is showing an expansion and contraction of thinking. So rather than starting with one big pathway towards one solution, we're constantly generating alternatives. So you'll see here that 1, 2, 3, and 4 are expanding design ideas. In other words, we're constantly introducing new alternatives and new options, but then constantly validating them through energy modeling, daylight simulation, carbon analysis, any kind of quantitative means to begin to make decisions about design based on evidence and not solely based on the designer's intuition for what would make something beautiful. And again, I'm not giving up on beauty, we're delaying the beauty to later in the process. So as you see, we do the same thing for passive design. And essentially, when I'm doing this, we'll do maybe 16 different options at each one of these. So each one of these gets 4 different options. Building envelope, active systems, as you can see here, we get into lighting and power density, HVAC and PV calcs, and eventually we get to net zero energy. The reference is midterm is the reference to how I teach this. And then we expand it again and go through a grand design synthesis where we're really looking at aesthetics and formalism and all kinds of really critical aspects. In defense of this, I will tell you that pathway 4 is an aesthetically generated path. Pathway 1 is performance-based, 2 is systems integration, 3 is culture and equity, and 4 is based upon aesthetics. So we're not ignoring aesthetics, we're not ignoring context, but we're reprioritizing the design process in order to generate the kind of results that we would like to see in the future. Now, this is a short presentation. I've enjoyed talking to you about this. I'd love to show you some examples. Please contact me. Please contact me by email at this website, and I will be happy to meet with you and send you some links and some other information. In fact, I'll include some links with my upload so that folks can go ahead and see some of the projects that are coming out of this process. Again, I want to thank the conference for letting me be on the panel and letting me share these ideas. I hope that I've stirred some imagination in you, and I hope that I've inspired you, whether or not you use this process or inspired you to find some new process. But I really would create a call to action here to not be a part of the status quo and to drive innovation as deep as possible, because our future depends on that. And with that, I will say thank you, and I look forward to hearing your comments.
Okay, the final presentation in this section is given by Mr. Zhang. Yeah, please. Ms. Zhang is a NGO manager of 350 organizations and the senior partner of Plan B. Please.
Great. Good afternoon. Okay, still awake. Okay, so this is Liang Yi. I'm really glad to be here, and I'll talk a little bit about like what is Plan B is about. And sorry for those who don't understand Mandarin. Some slides are in Mandarin, so hope it's okay. So today I think a lot of problems we mentioned earlier about climate change, a lot of like social issues and environmental issues. I'm not going to mention all of those, but this is from Einstein saying that it's really important that we shouldn't use the past thinking and to solve the problem today and tomorrow. So this is from the textbooks. I'm not going to say that. What is the sustainable development? It's mainly because for future generations. And there's a lot of the misunderstanding in Taiwan and across the region for what does it mean for sustainable development. So I'm trying so hard in the past 5 years and talk about this. So I'm trying, hope this forum, like all of you guys already know about this, but I'm going to go through a little bit. So in the past, there are triple bottom line principles about social, society, economy, and environment. And then in 2015, SDGs came in like to be on 5 principles of 5 Ps in short. So in short is that in the past, definitely the social issues, MDGs are like developing countries, in developed countries, they cross over supporting each other. But then in 2015, come together as a joint point, as we all know about Paris agreements, and it came into the holistic approaches, leaving no one behind, as we know. So you might already talk about this. There are 17 goals. There are a lot of issues like energy, circular economy, like SDG number 12 and 7. It's all linked. And in Plan B, we talk about this. We say that it's only 16 goals because the number 17 actually is a functional goals. So we need partnership like today. So I'm really glad to meet all of you guys and willing to talk more about this. Yeah, so the resources on the planet is going to running out. That's the main purpose for Plan B. So we are actually call ourselves like a backup plan. So what Plan B does is actually we do research, we do design, we do operation, we do planning, and then we hope to have the joint thinking and approaches that we call SD tools to have a new lifestyle for sustainable development goals. And for my part is actually research. Apology. So my part is actually doing the research. So when doing 2 sides, so one is developing tools, thinking models, like sustainable designing or circular design. I will mention now some of the cases. And the other one is actually SDGs. So this is the tools we've been talking about. And in the past, we use SOP, we use design thinking, we use big data a lot. But then we think that SD will be a new tool for the future generations. So for example, is one of the approaches that we use is that we use the SD tools plus the research, and we do a lot of reporting for different levels. I can talk about that a little bit. But at the beginning, during this pandemic situation, it's really honored to have Taiwan as this kind of forum, like to face-to-face. But there are a lot of needed trending issues, like there are more people moving to the city, so that cause a lot of issues when you want to do traveling, and there's calling a lot of accommodation issues for housing and for social issue for injustice. So there are a lot of problems happening across the globe. And for SDGs, actually in the past 5 years, every year globally, they are talking, using this as a common languages, let's say. So now it's 2020, and what we want to achieve in 2030 in the next future. So we said SDGs shouldn't be the PR tools and should be a real solution. So how can we circulate back on using these new concepts for new solutions? I'm going to talk about that. So in the past, Plan B been doing on 4 different part of the sector stakeholders, including public. So I'm going to talk about that first. And so general public is really important. And you might wonder like what I'm wearing 2 hats. So I'm also supporting 350. It's actually a global organization talking about climate change. And what we do approach is raising awareness in the universities, like in NTU and all the universities, to talk about divestment. So we are asking actually for 100% renewable. And also we are asking no more new fossil fuel infrastructures happening across the globe. And also we're asking no financing projects on fossil fuel industry. So that's how we call divestments. And I think you might know, like, fossil fuel industry have been dominating the power dynamic in the whole globe. You might know that ExxonMobil, or you might knew the news that actually yesterday, New York City, they just divested $226 billion for the pension fund. So all of your pensions will invest in new investments. We hope those investments can go to renewable and also new. So from till recent, I think there are $11 trillion being divested from the fossil fuel industry toward renewable industry. So, and we also calling upon a different local community to talk about human rights issues. So that we call Climate Defenders Project. So we're supporting a lot of that. But then I realized that in Taiwan, we need to have a real solution. So how we do it. So Plan B have been supporting to using SDGs and also climate change to talk about this and creating more solution. And one of the case study is to do the reporting. So in 2016, before the country having the voluntary national review, we did this shadow reports and we called SDGs New Sexy. So this project is mainly to submit only 50 reports to stakeholders, including legislators, including governors, including city governments, invite them and to educate them to do workshops. And then we play games. So we host the first party in a museum in Taipei, in Shiling. And actually, no one knows SDGs at that time. And then people will gossip about, so how many goals of SDGs? Do you know? 17. Yeah, then you get a ticket to get into the party. So basically, everyone didn't know, but then we're trying to raise awareness during that night, like at late night event in a museum, to educate people using a fun way, using a game way, and then to really raising awareness. And then of course, we also go to the UN conferences and to say that leaving no one behind, so Taiwan should be part of that. And also we're trying to engage into that Taiwan's case studies to the international communities. So after doing that with the public community, with general public, and we found out that actually the business play a key role on that, especially for the circular economy. So we think that SD thinking should be a redefinition for our lifestyle. So how we say that? So there are different sectors we've been working on in the industry in the past. So I'm going to raise some of the case studies. One is working with the design sectors. So we're trying to combine with circular design and also circular economy to link it with SDGs. So how we do that is basically, as you know, there are 17 goals, but how can we prioritize and link in all of that? So we'll prioritize into 5 categories. So there are direct contributions for number 6, 7, 8, 12, and 15, but there are all others in the different spectrums. And there are 169 targets. So we're also mapping out to provide us research to see how this project, for example, the recycled glasses or plastics, these kind of projects can link and contribute to global goals. So we think that not only the industry should play a key role, but also investors. So as you might know, ESG have been coming a key term recently. In August, actually, our government also launched impact investment, actually is responsible investments, a platform that you can get all of the information on ESG on the platform. So internationally, actually, all the investors have been coming together and into looking at how as investor can contribute to global goals. So I'm not going to go into detail for the TCFD or the ESG, but willing to help all the corporations here if you are willing to talk about risk and management. But for schools, for students, also really hard to find a good talent who know sustainable development, how we do that. So at that party, we actually invite all the principals to come to join the party. And one of the university from Tainan also really got interested in it. So we actually talked to the principal and say, hey, you have 9 colleges, but there's no college called sustainable development. So how are you going to teach that? So they said, okay, number 4. But then usually it's a cross-cutting issues. For example, like recycling link with engineering link with waste management, and waste management link with water issues. So actually, we also do the mapping for the schools. So there are actually 9 colleges. We help them to map what is your strengths, what's your weakness across different goals. And also, you can search 2030 and CKU, and you can find more information, all in English. So we also help the schools to map out, for example, one case study, one project, how it linked to, for example, cities project, smart city project, or AI project, how linked with that. And then we also help them to rank across the globe and also the region. And after the school, they were thinking that maybe the government should do more things, not the central government, but also city governments. Then we're trying to talk to the new Taipei city, saying that, hey, you guys should do your voluntary reporting. So we're actually using a creative ideas using SDG number 11. There are 7 targets below it. And then trying to engaging with the civil society, including a citizen, as myself, actually living in the new Taipei city. So number SDG 11, and then also global goals, and then also prioritize them, and also localize them into the targets. And we're having this interesting reporting, and then we're trying to host a Taiwanese style with 20 actually issues leaders, stakeholders sitting together and listening and talking about this, how we solve the problem together. Of course, it was a launch party and it's a continuous efforts. And also I think that Taipei City or Taiwan City and now a lot of cities are talking about this. But I think for these kind of solutions, very important thing is that to have the concept, no matter what you are doing, no matter who you are engaging. So I think that's a nutshell of my sharing today, and I'm willing to engage and to answer more questions afterwards. Thank you.
It's time for question and answer. Please, all the guests on the stage.
We have probably 5 minutes, so maybe we can have 2 or 3 short questions. Any comment or suggestions? Problem? Yeah. Sure.
Okay, so you mentioned that MB is doing research. So what kind of research that MB is doing? Are we talking about academic research or just case study? Just curious about
Okay. So we're actually doing 2 sides. So we're doing consulting researching. So we do management researching and also organizational development researching. And also for academic research, we did a little bit, but we not really want to focus on highly because I think all of the professors here are much well-known, all of the detail and data and case study than we do. So we basically do, as I mentioned, so consulting researching and also for coordination researching. So from local, regional, and global. So sometimes it's really hard to find the resources. For example, we say we want to invest in a solar panel in, for example, in Ilan, for example. Then it's really hard to know like what the skill and capacity on the ground. So we will help to keep providing the landscape and framework like to see how it goes. And then we will invite a professor to do the academic research afterwards. So it's mainly to initiate the project for the research, I think.
也可以请用中文。
I would like to ask Mr. Zhang about, can you describe more about how to educate SD students in Cheng Kung University? Can you describe more? Thank you.
That's really important. It's a hard question because we spent 1 year for that project. And the first challenge is to talk to a professor, actually. So all of the dean of all the colleges, they think that they are somehow relevant already, but they don't see as a scope of comprehensive approaches. So it's really important to set up by the principal to have a committee first, rather than me as an outsider saying that I'm going to educate you guys. So that's the first presumption that we're going to landing there as basic education projects. And second is that we provide the materials as a supplement data or supplements framework for all of the colleges, rather than adding a new work for them, because I think all of the colleges are really busy already, and the students are really busy already. So it's really important to let them understand it's not a new subject, but it's the existing project they are doing. So we're trying to engage with those students who are already doing something related to SDGs, but they don't aware that they can amplify to the international network, something like that. So that's really important, I think. It's not really educate them, but that them realize what they are doing is already linking with SDGs.
Hello.
Yeah,
May I
please.
ask questions? You mentioned the realization, so I will talk about the future wisdom usage of wind energy. Anyone can answer the questions.
Wind energy, can you repeat the question?
Wind energy is like recent research, they focus on wind energy, and then we talk about the realization, like the users, how we use wind energy wisely.
I can add a little bit. So I think in Taiwan, there are, I think, 4 or 5 pilot projects of the offshore wind farm are being implemented, and there are a lot of like foreign investors. So I think there are 3 different questions we need to try, our challenge that we need to solve together. The first one is a legal part, like how does the offshore linking with the environmental impact assessment, for example? Are we gonna be engaging with the public, or are we engaging with the right experts? For example, there are dolphins, there are fishing industry around those offshore. Like how are we gonna to legalize those in terms of the government side? And the second is the raising awareness. I think there are still a lack of understanding of how the wind link with the grid. With the Thai Power, I think it's trying so hard to raising awareness and including your household, like how your industry or factory like linking with that. Are you gonna just buy the green electricity? Is that linking with a wind farm or not? I think because all of the consumers need to know that they have the right to buy the green power so that they can driving forces to have more incentive for the industry as well. So I think this part is really lacking at this moment, as I know, among the community. And the third part is, are we gonna to have more training, or how to say, like skillful people like Danish or like foreign countries investors, just let them to like into Taiwan, like to have those wind farm? Or are we as a Taiwanese, like young generation, are we thinking that maybe we should start a new like wind farm company or collaborate with international engagement, or to co-investing a new company, corporation to grow this industry? So I think that's a new thinking that also Plan B thinking and supporting some clients as well.
Okay, thank you so much. Thank all the speakers, give us excellent content and future possibilities. Thank you. Please have a seat. 10分钟之后，我们进行第3场。We will have a third section in 2:40. Thank you. It's the coffee break time. 另外也欢迎我们经济部能源局的副局长已经到达会场，副局长好，欢迎您来。欢迎您来，李军李副局长，李军副局长待会儿是我们第3阶段的 speaker 之一，谢谢您。2点40分，再请大家回到我们的这个研讨会的现场。
好，那我先带您入座，然后我这边再去跟。
在2分钟，我们开始第3个场次。We will start the session 3 in 2 minutes。我们要请所有的这个工作人员帮我们引导所有的贵宾尽快的回到场中央来。We will start in 2:40 p.m. after 2 minutes.
Test.
如果方便，我们也请在场外的贵宾，请大家都准备入座，谢谢。第3场，我们的主题是新能源与环境技术。The topic of the third section is new energy, environmental protection technology. 那这部分呢，我们邀请这一场的 moderator， 我们欢迎 Professor 林坤松老师，欢迎。
Okay, ladies and gentlemen, it's my pleasure to be here. Good afternoon. It's my pleasure to be here to be the session moderator. I'm the Professor Lin, come from Yunzi University, Department of Material Science and Engineering. Yeah, so this session we have the 4 speakers. Yeah, and the first one is Mr. Lee, come from the Ministry of Economic Affairs. His topic is about Taiwan energy transition and renewable energies developing. And the second one is Ms. Dr. Lee, come from CPC. The topic is the battery of technology developing in the CPC. And the third one is the digital power. It's a very new topic. And the last one is Taiwan engineer from West. Is Mr. Diao, come from the ECOCE companies. And we are welcome to the first speaker is Mr. Lee, come from the Ministry of Economic Affairs. We are give a big hand.
Thank you, Professor Lin. Good afternoon, ladies and gentlemen. It is my great privilege to be here to share some information about the government energy policy. And today I will focus on the energy transition and the renewable energy development. And my speech will include, oh, okay. Sorry. Doesn't work. Would you mind help me to, okay, next. Next slide. My presentation today will include the current energy status in Taiwan and the energy transition policy and the renewable energy development in Taiwan. Next slide. That's okay. In Taiwan, 98% of energy supply rely on import. We don't have crude oil, we don't have natural gas, we don't have coal. Almost all the energy resources we use in Taiwan is imported from other countries. And we do have some indigenous energy resources, but it is very limited. The share is only about 2%. Most of them come from the conventional hydropower and the waste treatment. This kind of situation is a very severe situation for our energy stability and energy security. So we have to change it. Furthermore, the energy supply is keeping growth in the past few decades. It is not only harmful our energy security system, but also makes us to spend a lot of money to import the energy resources from other countries year after year. Why the energy supply is keeping growth in the past few decades? The reason is very simple, because our economic is growing in the past few decades constantly. And in order to cope with the economic growth, so the energy supply, the energy demand is increasing to support the economic development. So we have to import much more energy resources to meet the industry demand, to meet the commercial department demand, and to meet the household demand. Even though the government put a lot of effort to enhance the energy efficiency and to improve the energy conservation, but until now, we cannot decouple the economic growth and the energy supply increase. But I strongly believe the new technology will be the main driving force to decouple the economic growth and energy increase in Taiwan. So how to promote the new technology, how to enhance the new technology is very important for us. And aside from the imported energy resources or the energy supply, among all the different kind of the energy resources, we are heavily rely on the fossil fuel as well. We are heavily rely on the crude oil, the natural gas, the coal. And all this will create a lot of carbon dioxide emission in Taiwan. In Taiwan, we have a lot of coal-fired power plant, gas-fired power plant, the petroleum refinery factory, and a lot of diesel and a lot of the gas-fired engine vehicles. So all this will produce a lot of CO2 emission, will harmful our environment and harm to our health. So we have to do the energy transition. In regard to the energy transition, since President Tsai took office in year 2016, the government announced the Taiwan Energy Transition Policy. And this policy is based on 4 principles. First principle is we will create a nuclear-free homeland in Taiwan by year 2025, sorry. So that means we will decommission, we will phase out all the nuclear power plant by year 2024. And at the same time, we will decrease the coal-fired power generation and increase the gas-fired power generation and develop renewable energy. The target we set by year 2025 is the coal-fire will increase to 27%. And right now, in the current stage, the coal-fire, the share of the coal-fire is 46%. And the gas-fire will increase from 33% to 50% by year 2025. And we will phase out nuclear and develop the renewable energy to 20% in our power systems. This is the structure of our energy transition. So it's simple and it's clear and it's very transparent. And I will elaborate it in the next few slides. Okay, firstly, I will introduce about the nuclear transition. As I mentioned, we will phase out all the nuclear power plant by year 2025. And in Taiwan, we have 3 nuclear power plants, the nuclear 1, nuclear 2, and the nuclear 3. We do have the nuclear 4, but the nuclear 4 is under the construction stage and not finished yet, because we mothballed the number 4 nuclear power plant in year 2014, is about 6 years ago. And the rest, the 3 nuclear power plants, right now, the nuclear 1 is decommissioned. It's already decommissioned already in last year. We decommissioned the number 1 nuclear power plant in year 2019. And we will decommission the nuclear 2 by year 2023. And we will decommission the nuclear number 3 by year 2025, year 2024. The principle to decommission the nuclear power plant, what is the principle to decommission it? The principle is when the nuclear reactor running or operation 40 years, we will phase out it, because the lifespan of the nuclear reactor is 14 years. So we will not expand the lifespan, or we will not shorten the lifespan. So the last nuclear reactor we installed in Taiwan is in year 1985. So when we add 40 years, we will phase out it in the year 2025. That's why we will create a nuclear-free homeland by year 2025. So secondly, I will introduce about the coal fire. Coal fire right now is the major power supply in Taiwan. It's very important power supply in the past few decades. The coal fire is cheaper, is stable, but the problem is the coal fire will produce a lot of CO2 and the greenhouse gas emission and a lot of particles, SOx, NOx. So it is harmful our environment. So right now the government will have no new coal fire unit before year 2025. So the share of the coal fire will decrease from 46% in the current stage to the 27% by year 2025. And as I mentioned, we will phase out nuclear, we will decrease the coal fire. Since that, we have to find something to make up the power gap. And the solution is gas fire. We will increase the gas fire, and we will develop the renewable energy. And so for the gas fire, right now in the current stage, the share of the gas fire is 33%, and we will increase to 50% by year 2025. And if we want to approach to the target, we have 3 things to do. The first one is we have to increase the new gas-fired power unit. So right now we have the project to increase 12 gigawatt gas-fired power unit in Taiwan, and we have to finish it by year 2025. And secondly, we have to increase the import of the natural gas. Right now, every year we import 17 million tons LNG from other countries to Taiwan. Most of them come from the Qatar, come from the Middle East. And we will increase to 24 million tons by year 2024. But all this is not enough. The most important one, and maybe the most critical one, is we have to enhance our natural gas infrastructure. So there is a lot of work to do. We have to increase the receiving terminal. We have to add more storage tank. We have to storage much more security stockpile. Right now in Taiwan, we have 2 natural gas receiving terminal. All these 2 is built by CPC, the Chinese petroleum companies. One is in the middle of the Taiwan with the Taichung receiving terminal, and the other is in the south part of the Taiwan, what we call the Yong'an receiving terminal. And right now, the CBC is constructing the number 3 receiving terminal in the north part of the Taiwan, the 3rd terminal, or we call it the Datan receiving terminal. Aside from the CBC, the Taipei will increase their own receiving terminal. Right now, the Taipei have 2 projects is under the planning stage. The one is in the north part of Taiwan. We call it, this terminal is in Keelung, is the Shenao terminal. And the other is in Taichung, what they call the Taichung Port Receiving Terminal. So right now, we only 2 receiving terminal, and we have to finish the other 3 within these 6 years. And not only the receiving terminal, we have to install much more storage system, security stockpile, and the gasification system and piping system. So we have a lot of work to do. We have many things to invest. So this will create a lot of job opportunities in Taiwan. And the last but not the least is the renewable energy. I think I will skip this slide because I will elaborate much more detail in the next few slides. The renewable energy development. The renewable energy development is very important in our energy transition because renewable energy is not only the clean energy, but also the indigenous energy. As I mentioned, in Taiwan, the indigenous energy resources is only 2%. But if we can increase our renewable energy to 20%, that will be much more better, much more safer in Taiwan. So our target is increase the renewable energy power generation to 20%. That's okay, 20% by year 2025. And this table shows the renewable energy mix in Taiwan by year 2025. And if we check this table, we can find among all the different kind of the renewable energy, government is very focused on the solar energy and the wind energy, especially the offshore wind, because the total installed capacity will be 30 gigawatt by year 2025. And the share of the solar will go to 20 gigawatt. And the wind, include offshore wind, the onshore wind will go to 7 gigawatt. That means the wind energy and the solar energy will be account for 90% of the total renewable energy installed capacity in Taiwan. So maybe you will ask, why solar energy? Why wind energy? Why solar energy? There are 2 reasons. First is Taiwan is rich of the solar resources because we are located in subtropical area. But this is not the most important reason. The most important one is Taiwan have a very strong solar industry. Taiwan is the 2nd largest solar cell producer and export country. So when we promote solar energy, it's not good for our environment, but also benefit our local industry. In Taiwan, we have a very mature and complete solar industry supply chain. And why we focus on wind energy, especially the offshore wind? The first reason is easy because we are rich of wind resources. We have strong seasonal wind, especially in Taiwan Strait. It's one of the best offshore wind farm in Taiwan. And the second reason is Taiwan is a small island. We don't have much room, much space to install so many renewable energy, especially the wind energy on the Taiwan, on the inland. So we have to go to the offshore. We are a small island, but we face the big ocean. So we will develop the offshore wind in Taiwan. And all this will develop very well in Taiwan. I will introduce much more detail. As I mentioned, the solar energy of the solar energy is increased to 20 gigawatt by year 2024. But we start from only 0.0 gigawatt in year 2015. That means within these 10 years, 2015 to 2024, within these 10 years, we will increase 40 times of the installed capacity. So we have to promote the solar energy from the rooftop system and the ground-mounted system. As for a rooftop system, our target is 6 gigawatt by year 2035, and we will use the public building, the factories building, and agriculture facilities building. And we will use all the building to deploy the rooftop system. And in regard to the ground-mounted system, the land-based system, the target is 40 gigawatt by year 2024. But as I mentioned, Taiwan is a small island and the land is very limited and the land price is very expensive. So the priority, we will use the land cannot harvest the food crop, something like the contaminated land, because we have a chemical industry in Taiwan in the past few decades, and some land is contaminated by the chemical materials. Or some land is the subsidence, severe subsidence, and because we do the aquaculture farmer, they pumping the groundwater, and they pumping the groundwater a lot. So the land is subsidence. Right now, the government forbid them to pumping the groundwater. So they cannot do the aquaculture, and then can change to deploy the solar systems. Or we use the closed land field to deploy, or even the pond or the lake, we will display the floating system in Taiwan. So right now, the PV system developed very well in Taiwan. Each year, we have approved more than 4,000 cases, 4,000 projects about the PV systems. As for the wind, as I mentioned, we focus on the offshore wind because we have great potential to develop offshore wind. But the problem is we don't have any experience about offshore wind. We don't know how to develop offshore wind. So if we want to approach our target, we have to develop a strategy. So the strategy, we divided it to phase 1, phase 2, phase 3. In the phase 1, at that time, we don't have any experience. So government set the demo project. Government provides the incentive to the pioneer, to encourage the pioneer to invest the offshore wind project in Taiwan. And we approved the 2 projects. The total capacity is 238 megawatt. And one of the project is finished, is operation in last year. The capacity is 128 megawatt. The site is located in Miaoli, the Longfeng Harbor. So right now we have the experience, and then we will go to the zone application for planning. That means we will open our market to the international experience, the enterprise to come to Taiwan, to cooperate with the local enterprise to develop the offshore wind energy in Taiwan. And right now we approved the 10 offshore wind project. There are my experience, the international offshore wind developer come to Taiwan and cooperate with the Taiwanese to develop the offshore wind. And the total capacity is 5.5 gigawatt. So right now we are going to the third phase, is the zonal development. That means we will open the market to all the developers. They are interested in Taiwan's offshore wind farm. So right now the government is, we have a draft about this, but it's not in our planning. We will schedule to finalize this project by the end of this year. And this is the draft of the phase 3, the zonal development. And under the draft, we will increase 10 gigawatt between year 2026 to 2035. And the mechanism to select the candidate will divide it into 2 phases. In the phase 1, we will do the capability review, and we will focus on the technical capability and the financial capability. And then they will go to the bidding process. And because 10 years is very long, so we divided it to 2 phases. The first 5 years, we will open 5 gigawatt, and the other 5 years, we'll open the other 5 gigawatt. But I have to emphasize all this is just a draft. Right now is in the public hearing and the public consultation stage. So I hope we can finish it within the end of this month or next month. Okay, finally, I have to emphasize green energy is the core of the energy transition. And no matter what kind of energy transition policies, the most important thing is to ensure the stable power supply. And the government will put all effort to reduce the carbon emission. And finally, I have to emphasize, we are confident to achieve the goal. Thank you.
Thank you, Deputy Director Lee, giving a very clear the outlines for the Taiwan policy, power policies. Okay, the second speaker is Dr. Lee Cho-jin, is a Deputy Director of the Green Technology Research Institute of the CPC Corporation. We'll give a hand to welcome Dr. Lee.
Thank you. My name is Chu-Ping Lee from CPC, Taiwan. I apologize, I chose use Mandarin to give this talk, and somebody gonna translate for me for the video later on. Anyway, 所以谢谢啊，在这个今天呢，唯一用中文的，因为啊，这其实中油公司啊做电池大家非常的陌生啊，很难得出来啊，所以有讲不好的地方，就请大家contact with my colleague，OK。首先呢，很简单的介绍一下 CPC 哦，虽然大家都很熟悉了，然后我们面对的问题，刚刚我们的长官已经说明了，现在因为政策的改变，然后呢，我们介绍一下这个我们最近我们做的绿能所做的这个新单位所做的这个电池的技术，然后最后介绍我们还使用的这个反溢流的一个技术，那这是我们中油公司的话，就从探勘开发，然后进口，然后就是 marketing， 就是所有的加油站呢，大家都可以看到，所以每个人住在台湾都知道 CPC 台湾。刚刚所讲的基本上的话呢，全部的能源所有的原油呢 ，crude 基本上140个 million barrel 呢，就是从外面进来哦，然后呢还有加油 ，sorry。所以加油站这是106年的一个 data 啊，然后刚刚李副局长所提的这个天然气的话呢，现在目前台湾全部都是天然气都是中油公司啊，那未来的话，刚刚有台湾 Power Company 也将会建啊，其他的话大概是这个石化事业部在106年的时候是赚最多的，这是就是有这个循环的一个这个经济循环的一个，那中油公司为什么会必须做电池？这个就是我们在带董事长开始的时候呢，必须强迫我们在开始进入的原因呢。我们加油站所提供出来的汽油呢，汽车呢将要慢慢的停用了，所以呢，我们将未来的石油呢，预期来说的话呢，是每一天呢会减少800个 barrel。然后呢，这是预期的原因，是因为每一个公司 international 所有的那个的 car 呢，都是慢慢的呢就停用了所有的 fuel 这个的汽车哦。所以台电给我们的这个 data， 在台湾1400，中油公司是 local company， 然后在台湾来说的话呢，1400部这个汽车，如果全部用电动车，机车1400部，然后汽车是600万部的话，这样来算出来的时候呢，全部都改为电动车的时候呢，将会将近14% 电。然后呢，这是年度的电。那如果说一半的话呢，也是将近到6% 超过6%。所以不管怎么样来说的话呢，当汽车一改变的时候，当你电动车一出来的时候，将会改变到所有的一个用电的习惯。何况刚刚这个能源局副局长已经提到了，我们将又要变成这个绿电的时候呢，是影响的非常的大。所以呢，在配合国家政策情况之下呢，我们希望今天的中油是用这个fossil fuel 去提供给大家服务。那未来的话呢，我们能够呢有一个新的 business model， 然后呢能够很方便的提供这个充放电，然后就是充电，然后呢能够对于台电的这个整个电网呢这个 grid 呢都不会有任何的冲击啊。然后这是一个 model。所以呢，在2年前开始一个就是我们现在所谓的这个green energy 呢 smart gas station。所以就是一定要会有这 energy source 来说的话呢，刚刚讲的 PV， 然后呢也会有就是我们可能也会有 natural gas， 然后就是 SOFC 或者是 PAN。那现在 demo 的话，等一下会说明一下。然后呢会有一个energy storage， 就是储能的设备，然后再来 usage 的话呢就充电桩。那目前来说的话呢，我们在1年多前，1年多前，所以完成了在台南的前锋站跟这个嘉义的信义站。那这2个站呢做 demo 也1年多了，我们不停的被 evaluation， 就是评估到底是怎么回事，然后这个效益是怎么样子，不停的在追踪这些事情。在信义站的话是嘉义，在嘉义的欢迎大家去啊。这个部分来说的话呢，这个 PV 来说的话呢，我们放了这是109个 kW， 这个太阳能的这个 PV 的一个 system。然后呢，这是台达电所做的一个这个 storage 的这个储能的设备，是3元的。然后呢，它大概提供了500度电，然后给这个加油站的充电桩。目前为止来说的话是，最多的话就是提供给这个 Gogoro 跟中华机车充电。所以这个应该是是什么？反正送吃的那个一天到晚去加。那在前锋站来说的话，这个就比较复杂的，就是我们绿能所负责的。所以呢，因为它的站体比较小，所以大概是加上19个 kW 的一个太阳能，加上我们放在宿舍区里面有30 kW， 所以它事实上呢是很有限的一个太阳能的供电。那我们旁边呢加了一个 Panasonic PAN 的一个 fuel cell 的一个这个供电24小时。其实基本上的话，现在 model 的话是22小时，然后停2小时，然后供。由我们中油公司就是提供给在宿舍那边的话，就会有提供电。这符合能源局对这个加油站的安全的一个管制。然后呢，在加油站下面的话，是我们现在用我们公司的就是我们的材料里面的话 ，LTO 的一个设备是50度电。然后呢，还另外一个反溢流，就是用反溢流的一个的一个储能。所以我们现在应用在那个站的话，在台湾前锋站的话是这2个，然后提供给这个场域前锋站在成大的后面来提供。所以 overall 来说的话呢，其实怎么样来说，在我们的这个绿站的话呢，其实在今年会有另外2个会出来，在桃园，然后还有一个在花莲。那因为还没有开幕，所以我还没有画上去。那明年的时候慢慢就会出来。那这2个的话，侧色是可以移动式的。那这部分来说的话呢，那储能事实上的话，除了水力啊，然后这个空气啊，这部分来说的话，其实我们可以思考的就是我们用的一个单位成本。其实储能一直是单位成本比较高的，然后除了能源绿电已经很贵了，还再加上我们还要再加上一个这个储能的一个成本下去的话，我们将会面临到这个它的成本的高。那所以我们在选择的话呢，我们朝这2个 就是锂电池跟这个反溢流2个去处理，所以刚刚可以看到我们在这2个绿站里面来说的话，用这2个，但是所有的压力都一样，它的成本高呢，在未来的时候你必须要去符合到水坝的这个水的成本，这是我们将来符合整个世界潮流的局势之下的话呢，必须要再继续下去，成本必须这样下去的时候，我们唯一 strategy 了，就是我们必须它最好是 long life。如果是把它这个如果可以用20年的话呢，不管这个符合循环经济，也符合了这个成本的一个下降。所以呢，因此呢，我们在这几年来说，我们大概做了将近5年了吧。然后呢，所以用来虽然我们很少在外面宣传的原因，是因为很多东西还在改进中哦。那目标来说的话呢，我们目标就是要做这个锂太阳电池跟这个高能量的锂太阳电池，这是我们的目标。那这个部分来说的话呢，目前还在努力中。循环寿命的话呢，一定要上万。然后呢，我们充电的话，这边写20C 哦，我们同仁很勇敢哦。通常来说的话，我现在目标都是5C，我知道差很多啊。这个 C 1小时这个20到5啊，但同仁都写20C 啊，这个写到2万哦，我也是觉得很勇敢了。但是他们写出来，因为要跟现在的锂铁跟锂3元跟这个铅酸呢，跟反溢流再比较来说的话，另外一个就是反溢流，这也是另外一个我们在着重的一个目标。这2个电池的一个发展呢，是我们在努力的目标。那中油在这个目前你们在新闻里面已经有看到了，所以我们增加 double 这个配合经济部的政策，我们研发预算 double。那最大的一个增加的一个幅度在于电池。那中油公司要做什么东西？我们中油公司哦，目前呢，那长官如果命令是这个方向是不一样的话，我们就配合办理，就今天讲话就不算。所以因为很多不算了，所以就是模糊的讲过去。那我们希望我们中油公司，我们希望啊，那随时会改变。我们希望我们能够做一个材料的制造商。然后呢，我们希望 joint ventures 的这个 business， 就是我们 local business partner 能够在做这部分模组跟 battery。目前的话，我们有 content 几家公司哦。然后呢，最后呢，其实为了在我们台湾能够技术生根的时候呢，验证平台必须要做，因为事实上在这几项的一个技术来说的话呢，事实上目前都还在开这个起端。虽然我们起步的晚哦，事实上全世界的技术也是在努力中哦。那我们考虑一下我们的材料啊，正极材料的话呢，锂钴啊、锂锰啊、锂铁啊，然后这个3元啊，然后锂钴锰。这个负极材料来说的话呢，这个当然中间的电解液，然后负极材料的话呢，这碳系啊，这个 LTO， 然后还有这个中碳的这个 MCME， 然后这个我们中油公司绿能所我们基本上的话会走到软碳去，然后呢也参与这个我们就建制在明年底的话，或到后年的话，这个我们会建厂做 LTO， 所以呢。基本上来说呢，这2边的一个材料呢，我们都已经开始在拍了，以及会大概再过2年，应该生产工厂会出来。然后呢，其他的这些细碳啊，这些细碳的话，因为就符合这个 technology 发展呢，我们还是会做的，这个同仁还是都会做的。那第一个介绍的就是我们。在猎研所研发的技术来说，从 resid 开始，就是从我们的重油里面去开发这个软碳，然后从重油里面的话，就是我们的 button 里面的话，原油里面的 button 呢去做着生焦，然后呢把它变成这个 powder， 然后再 calcination 啊，然后这个筛选啊，研磨筛选啊，然后再跟沥青混合，再把它碳化。形成我们的软碳，它的用意在哪里？它的用意第一个就是高质化，OK， 也是没事。那基本上来说的话，就是我们经过这个试量产完以后呢，事实上呢，验证它的性能呢是可以，所以试量产。那加了这个软碳的话呢，因为我把公司把它关掉了，就是我怕引起争议啊，所以呢，基本上在 local 来说的话呢，你可以看到那鸡排的话呢，大概用1200次啊，然后甚至在其他的话4000次，但是我们希望加了软碳以后呢，能够到达500次啊，所以要越长寿命，要越安全，是我们中油在开发材料的最重要的一个目的啊。那这个另外的话，就如果说我们今天充电的话是4到3C，就是充电的速度要高的时候呢，我们中油公司的话也还是可以达到4次，这是软碳的一个技术啊。那我们讲到第二个是最重要的是这个锂太阳。那锂太阳来说的话，为什么我们要开发这个的话？因为第一件事情，大陆不做，大陆做的事情我们实在是抢不到。所以呢，最重要的是，中油公司最重最重视的就是 safety。它是在 LTO 来说的话呢，它最佳的就是它的安全呢，安全不要写在哪里了，然后安全在这个地方哦，但是它的成本跟功率的话会比较低。所以为什么不做的原因是因为这两个。那这个怎么样去克服呢？事实上我们等一下会说明哦。那它为什么会安全呢？就是因为它 three dimension 的一个结构。这个，然后平常的话 ，graphene 的话是一个 2 dimension 的一个结构，所以造成这样子。那基本上来说的话，再 focus 一下，就是因为它没有 SEI 的形成，所以它会比较安全，然后 long life， 然后非常这个 excellent power performance 啊，然后这些，还有在这个 low temperature 跟 high temperature 下，它是一个非常好的一个性能啊。那这是我们建厂，那基本上的话，同仁在 study 的话，我们加的一个添加剂啊，这些东西在这些的话增加它的性能哦，能够其实我们测试过日本的，现在目前来说的话，LTO 的话，日本跟韩国这2个国家哦，然后大陆。当然，就因为他们不重视的话，事实上他们的性能是没办法跟我们比的哈。那现在已经证实，我们大概都 OK 的，就是跟日本跟韩国都 OK 的。然后这是我们这个做实验的一个结果。这因为时间的关系，我就跳一下。那我们这几年来的话，除了材料从试量产出来完以后呢，我们做了比较要到达商之前呢，其实各个家的那个大厂里面，我们都去测试，请他们实验线里面出来测试。到今年，我们请格式测试，通常都会盖起来哦，但是这我来不及盖啊。就大家看一下啊，其实最重要的一件事情哦，大家可以看到，平常如果到10C的时候，这个1个小时10C去充电的时候呢，其实温度来说的话，如果是3元的话呢，通常都会上升到20度以上，甚至到30度。其实你看到格斯的这个设计的这个软包设计的时候呢，它只从25度的话呢，一直到31度10C的情况之下，还只升3度。其实这个性能是非常好的，因为它的一个实验室的一个这个环境啊。所以刚刚所讲的所有的电池的一个这些测试来说的话呢，我们用到奇阳的一个摩托车上面，目前还在改善。这个我们实验室里面的一个这个启动机，然后呢，事实上在我们前风站里面50度的，事实上跟油量合作的这个部分来说的话呢，我们性能的话，今年的 data 全部都出来哦，都会检讨，很欢迎各位到现场去看。然后呢，在我们中油大楼里面的话呢，有个 UPS， 然后因为这个地方哦，是我们最早的一个 case， 那我们用的是日本的一个 ISK 的一个粉末啊，事实上最近也换了几个，但是我们会 monitoring 所有的电池里面的一个状况，也换了几个。这个部分来说的话，我们都在继续进行。今天所有的 data 来说的话呢，事实上不够好的。未来的方向来说的话呢，我们希望为了增加它的能量密度的时候呢，其实在负极材料以及正极材料的话，我们也陆续已经都在实验室完成了。实验室完成来说的话呢，尤其在正极来说的话呢，镍锰酸锂的这个正极材料，我们在实验室已经到公斤级的情况之下，我们放在嘉义这个地方在测试。先说这个技术的话，在实验室里面的话，从工研院过来，那我们目前都在合作。那如果等到这个在验证好了以后呢，我们会 这个搭配 LTO 的一个情况之下，因为 LTO 因为能量密度的低哦，所以我们必须要有一个高电压的一个正极。那这部分来说的话，我们就跟 LTO， 这是半电池的一个结果。然后这个测试经过 modification 完以后呢，实际上测试的结果也非常的好。那我们就跟 LTO 搭配完以后，目前实验室的 data 可以到达了这个快充快放跟慢充快放的情况之下，其实有符合我们现在目前现阶段的目标，但是未来的进步需要更大的一个进步哦。那还在改当中，因为 life cycle 一定还要再增加哦。这部分来说的话，我们会再改善。所以我们 overall 来说的话呢，经过我们这样子未来的一个开发来说的话呢，电池的一个目标来说的话呢，我们希望 battery cost 来算每度每 cycle 的话呢，希望降到跟一定可以抵得过铅酸，这是我们的目标。那一直到建厂的话，也必须要确认完以后，这个 pilot 确认完以后，我们才会建厂。所以基本上的话呢，就是很简短的，因为时间已经过了。那我们在 battery 来说的话呢，因为我们做的实证以及这个材料厂的话，慢慢都在进行中啊。其实另外一个地方。也是一个我们在进行的一个电池，就是反应流电池。那反应流电池的原因是因为我们的厂里面呢有反触媒，就是那个 RDS 的触媒啊，这个会做一个循环经济啊。那循环经济这个部分来说的话，我们大概是因为它是就是已经影响到这个环保的问题哦，所以我们大概会在明年后年来说的话呢，会再来处理这个把我们的废触媒然后变成电解液的一个情况。这部分来说的话呢，我们会再慢慢进行。那因为技术上应该是不会有问题，那未来也许我们有一天会扩大反应流的一个电池。我今天报告到这里，好，谢谢。
We hope we can bring new CPC in the future. Okay, the third speaker is Chief of Green Energy in the Environmental Research Lab, Dr. Liang Pei Fang, Mr. His title is Digital Power. I think it's a brand new topic. We'll give you a hand to welcome.
Good afternoon, everyone. The topic is digital transformation for power system. I'm Morris. This is the outline. To begin with the presentation, I think everyone knows that we have the Greenhouse Gas Reduction and Management Act in 2015. There is a big target in the carbon reduction, that's 50% reduction in 2050 compared to 2005. So we may ask where's the greenhouse gas come from. The majority of the green gas is carbon dioxide, and over 95% of the carbon dioxide comes from burning some fuel. So almost 70% of carbon dioxide comes from the power system. We use power, the factory use power, and maybe the department store use power. We take the responsibility of 70% carbon dioxide in our daily life. So we may ask, how do we reduce to that target? So how much green energy has to be introduced to the power system to meet that goal? The green power, the renewable, has almost no carbon emission. So we say zero. So we may think that so we have to introduce 50% renewable into the power system in 2050. That's not correct, because the power consumption is still increased. The average increase is about 1.5% currently annually. Even we reduce it to 0.9%, we have to struggle for energy saving, for improving the efficiency of the apparatus. we may still need to reduce we may still need to introduce 50 renewable early in 2040, because the power consumption increase. So we may discuss how should we do today. So let's see the demand supply scenario. This is in 2025, an estimation. This is the power consumption we say to be load, because we have renewable, especially the solar PV in the daytime. So the load is decreased. This is we say to be net load for the red curve. It means the conventional power has to provide the net load because we have the renewable. And you can see that the peak load becomes is shifted to the night, because we have plenty of renewable in the daytime. So the bottleneck is shifted to the night. And this is the winter, the same in the summer or in the winter. So this is the first phenomenon when we have plenty of renewable. We will have 20% renewable generation in 2025. If we look at the 2040, it's still an estimation. And this is the load. The load is the red curve. And the blue line is the renewable power generation. Because we will have 50 power generation from renewable, we will install a very high capacity of renewable. It will exceed 65 gigawatts. And the peak load is in this winter. It's the Chinese New Year. It's only about 25 gigawatts. So we will have surplus of the renewable in that day. So this is the problem. That makes hurdles for the conventional power operation, because you have shut down many conventional power plants. But it's impossible to release all the traditional power plant, because we need some adjustment real time. So we have to keep some of the conventional power unit online. So it's a problem. The other problem is the duck curve. We heard many times the duck curve currently, but it's not serious in 2025. But it will be a big problem in 2040. You can see it's over 100 megawatt change during 2 hours. So the conventional power plants have to run up very fast to provide the net load. So this is the problem. And when we think of 2040, the electrification is a must. We will have many electrical vehicles, and we may shift to electricity in the cooking and the showering, because if we use electricity, the carbon reduction is easier. When you use when you burn gas for cooking, it's almost impossible to deal with the carbon emission. But if the carbon emission is take place in the power plant, it's much easier. We may capture it, or we may just use the renewable to eliminate the carbon to eliminate the carbon dioxide. So electrification is good news and also bad news. We say it to be the bad news is that the electrical vehicle may increase the power consumption overall for 5 to 10%. And the household electrification will get another 5 to 10%. So we have we need more electricity for the electrification. But in the other hand, we will have more control capability when the cars use electricity. So it is possible that we have the devices, the cars, to help the grid operation. So there are other issues in addition to the last slide I show you, including the intermittency, because there are fluctuations of the renewable. Say in Texas, last once the wind power reduced 20% in a single hour, 20% loss from wind in a single 1 hour. So that's 4 gigawatt. So if we face that kind of problem, we have to be prepared. And also the system inertia will be much less. I mean that the inertia is like if you have a big car, it's hard to push it. The turbulence has little impact to the car. But if you ride a bicycle, it's much easier to push you down. So when we introduce renewable, the inertia is very little. It means the system are much more sensitive to disturbance. In this case, it's a simulation. The load 38 gigawatts like the peak load now. If we have 4 gigawatt renewable in that system, it's about case now. And we lost 1.2 gigawatt generation set, a big power generation set tripped. Maybe the cable disconnected, maybe there are some accident. The frequency will drop to 59.85. It's still safe. But if we have 8 gigawatt renewable, it goes deeper. It's 8 gigawatt, right? In 2040, it may be 30 gigawatt or 25 gigawatt. So it goes down. And if we don't have a proper reaction, the power grid will collapse. So we have to do something to operate the power grid with high renewable share. There are two things only. The first is to integrate more resources that are controllable, or we make them controllable. Say any storage system is controllable. You can command it to release power or to charge. The demand response, not so controllable. Demand response means the user control his load, manages load due to the command from the power grid. It's not so controllable, but we have to do something to make it more controllable. And also the district resources, like there are many uninterruptible power systems, the batteries in the factories, and there are backup power generators in factories. It's not connected to power grid currently. And if we want to make the power grid more flexible, we may have to think of a way to integrate this kinds of source. The second thing is to be more sensitive and smarter. Say we have to install more sensors. We have to make forecasting, especially for the renewable. If we have alarm for the sudden drop, then we can be prepared. And we have to integrate artificial intelligence to diagnostics and decision making to make a decision smarter, faster, and deploy the control actions. And the last one is to have some distributed control over the power grid so that it's more robust. So here's some examples. The first thing is that we have to make the infrastructure stronger. Say we have to install we have to build a good infrastructure for the integration of information. Currently, many of the type power subsystems are separated. They did not talk to each other. An easy example is that your bill, you receive an electricity bill. The billing system is not integrated with the smart meter system now. There are many manual jobs inside. So a good information integration needs the say a good communication bandwidth, data storage, and reliable service, and so on. The second is to for the cross-system data exchange, we need some standards. We have to introduce the standards. Say the common information model, that's IEC standards. There are many standards in IEC about the power grid. This is IEC 61968 or 61970. That's famous standards. And also the 61850 is for the transmission and distribution power grid. It's for automation. And for the end user smart metering, it's IEC 62065. Taipei is now trying to introduce these new standards into their systems. That means a lot of fundamental works inside the power grid. Another thing is to integrating more devices in the power grid. This is an example, the smart inverter of solar PV. Before, the solar PV is connected to the power grid via an inverter. That inverter will try to make the maximum power output to the power grid. It generates power, generate energy to earn money from Taipei, right? But there's a thing called 虚功, that's VAR. If you output VAR, you will not earn money, but you support the power grid. You can maintain the right voltage. Sometimes the voltage goes up or goes down, and the inverter can help the power grid to maintain the right level of voltage. In that case, you are not outputting, you are not, you do not output the real power. It's VAR. So Taipei introduced a new standard in this year. From now on, all the inverters of solar PV has to be smart inverters. That means all the new inverters has to help the Taipei has to help the power grid to maintain the good power quality. A second example is the automated demand response of small air conditioners. We use air conditioners every day. So in your house or maybe in your office, and the government has a new policy, 班班有冷气. In this year, that means the government will install air conditioners to all the classrooms of high school and elementary schools. It's about 200,000 machines. We will install it in 2 years. And because we introduced so many new air conditioners, we are thinking that if we can control the air conditioners when Taipei has some emergency. So this time we introduced a new protocol, OpenADR. This is the first time Taiwan introduced this protocol. The protocol will give a command to the schools so that the energy management system will manage the air conditioner, turn it off, or maybe increase the temperature setting to reduce power. And the important thing is that the home appliances is dumb. It did not talk. It does not talk. So there is a new standard called TISIA 101, or it's a national standard, CNS 16014. This protocol enables the communication of our home appliances. So the appliances can talk to some information system. So applying these two protocols to that case, we will have the air conditioners in school helpful to the power grid. So furthermore, we can do more things. Say we can link information of household devices to the grid more. Say we may have solar PV in many households. We may have energy storage. We may have batteries in the future. In Japan, in Australia, or in Germany, there are many homes equipped with the battery, maybe 4 kilowatt hour, 8 kilowatt hour. In someday we will face the same situation. So if we have energy storage system in house, it's possible to help the power grid and also electricity vehicles. So in our idea, the TASIA 101 will be expanded to this sort of energy devices. And also we have standards protocol upwards. So it will go through the smart meter, to the head-end server, and to the application servers. We can do many things. And the second is to integrate more devices in the distribution system. That means the distribution automation currently control the relays only. So the substation has some connection to the say 2 or 4 relays on the feeder line. But in the future, we may have we will have smart inverters. We will have voltage regulator or other devices to manage the power quality. They should be connected with a new information system. So this is a way we will improve the distribution automation. And also there are many other things going on. So here is the listing. We are not starting from zero. There are many things ongoing. Say the transmission and distribution automation. We have 10,000 feeder lines. About 70% are equipped with automated relay currently. So about 20% of the relay on the feeder lines are automatic. Taipei can watch the information or can switch it on and off remotely. And so I will now read it thoroughly. So I mean, there are many things on the way, and I think many people, many companies can contribute to this kind of new things development. So to end up with my presentation, the renewable integration needs the digital transformation of power grid. It's to support the renewable. There are 2 things to do. One is to enable the integration of new resources. We need information system, communication system, new devices. The second is to make the power grid more sensitive and smarter. So we need new algorithms. We need distributed control, and we are on the way. Welcome to join us. Thank you.
Thank you. Yeah, we hope that we have a more smart integration power system in the future. Okay, our last speaker is Eric Diao. Is come from Xinding Environmental Service Corporation. Would you give a hand to Mr. Diao?
Yes, good afternoon, ladies and gentlemen. And to make my speech more clear, I would like to follow Dr. Lee, use Mandarin to have my speech. OK， 我还是用中文讲好了哈。那我今天介绍的是就是 Energy from Waste 这个产业在台湾过去的发展和我们往前看的一个前瞻的一个看法。那这个也是刚刚能源局李副局长提到的，我们 biomass 这一块，好 biomass 这一块的这个再生能源里面，我们接下来会再走的一个方向。那我当然对前面的还有就是现在的现况，然后一些国外的一些经验，还有对未来的一些期望。那台湾这个废弃物的一个处理，那从在上世纪的80年代，那环保署那时候就很明确的，从原来的就是掩埋的方式，在80年代他决定要采用焚化的方式来处理废弃物，所以从1991年他那时候有用焚化为主，掩埋为辅，到后来全部都是焚化，历经了这20年的一个发展。好，历经已经快30年的发展了。好，那目前台湾总共有26座盖好的大型都市垃圾焚化炉， 其中有2座因为土地的议题还有环评的议题并没有实际营运，所以目前有24座在营运。那这24座有一个特色在，就是它由政府拥有、政府营运的有5座，然后呢，政府拥有交由民间来营运的有16座，另外呢5座的有3座在营运的是民间投资、民间营运的，所以而且时间顺序刚好是从上往下，所以在台湾废弃物处理的历程其实跟国外我们看到现在大陆或者东南亚国家都不大一样，大陆国家都是一开始就是用民间投资，可是台湾事实上政府做了很好的榜样。先用政府确定的规范、确定的这些水准标准以后，然后逐步再做一个民营化的一个过程。那事实上，整个台湾这样子废弃物处理的一个产业，其实有几个特色，我这边总结一下。第一个的话是原来的一个标办模式，它一开始前面4个案子，内湖、木栅、新店、树林，我发的是国际标。好，那时候台湾还没有对应的这些技术和对应的产业，但是后面的标变成混合标，到后来变成纯粹就是国内标。那也就是在这样的过程当中，另外在这些标办的过程，在中间的混合标都规定要有必须要一定程度的技术转移，同时还有就是要在地化的设备供应的一定的一个比例。那另外呢，有超过这个可能简报用到不同的档案了。刚刚那个档案是这个是不是？好，那我就用这个档案讲。那另外的话就是不好意思，另外的话就是它后来民营化，所以有80% 都是民间的方式在营，所以整个产业的一个发展，实际上也健全了台湾在焚化炉处理这块的一些产业。那我们这20年下来以后，实际上我这边举两个台湾我们自己建造的苗栗焚化炉，还有乌日焚化炉，这都是台湾自己做 EPC 整合，把整个建厂建材起来，然后而且是由我们自己台湾人在做操作营运的。那这过去20年，我们在08年的时候，其实是在某个程度也算是亚洲之光啊，亚洲在台湾之光，然后让很多的国外的人都来做参观。那同时呢，我们也用这样的一个时机，我们到澳门也拿到了10年的一个焚化炉的一个操作合约，所以等于说是这个产业在台湾有生根，而且有走出去发展这样子的一个程度。下一页。那当然，20年走下来，目前就面临到一些挑战了。因为刚刚讲到，从08年到现在都没有新的焚化炉建设，同时呢，在24座焚化炉都已经差不多20年的一个寿命了。所以在这时候，我们也面临到说，下一步我们这个产业接下来要怎么走？所以我们这时候考量看看我们这些国外的一些经验。其实早年的时候，台湾在规划的时候都是用美国的法令，环保署很多法令都是参考美国 EPA 的一个法令来做规划。但是呢，美国的一个特色是这样子，它的焚化产业，因为它有很多的土地掩埋，所以它在焚化产业到后来到20世纪以后，几乎美国的新的法令没有在进步。那整个的世界的一个趋势，其实是欧盟的法令，它从2007-6EC 到08年、14年都有持续有新的一个法令。所以欧盟的法令应该是现在在 EFW 这个产业最主要的一个主流。那另外的话，当然欧盟法令里面，它在08年的这个就是强调我们要做一些回收再利用、废弃物管理的一个政策。我想今天在早上赖处长的演讲应该有类似的一个观念在。那再回到技术本身的话，其实它有几个很主要的特色。第一个是它能源效率的提升要求，要从60%，这是热回收效率 ，60% 提升到65%。那相较于台湾的24座既有的焚化厂，其实我们的热回收效率，内湖最早的24.3% 而已，到桃园南区这个也只有61.9%，来落后目前的一个要求的一个能源标准。另外呢，它对于空气污染排放的要求更加严苛。台湾的法令都是1小时1小时在看我们污染排放有没有超过，在欧盟的法令，它甚至短到可能是10分钟或者是半小时，来要求你在更短的一个时间幅度里面都要满足环境法令的要求，而且当然它要求水准会更严。那另外的话，它会特定一些操作的一些要求，比如说你飞机系统有设备故障的时候，它会要求你进料就必须要卡断， 所以透过这样子的方式，它很严苛的要求所有的焚化炉在新建和营运过程。另外呢，我们也看了国外的一些案例，其实他们也都会慢慢有一些废弃物整合中心的概念在。废弃物进来以后，在厂内做收停，有机废弃物又走有机废弃物的处理方式，厌氧消化。那么其他可释燃的才进到焚化炉里面去烧。那焚化炉也用新的技术来提升它的一个蒸汽和蒸汽的压力跟温度，整个效率的提升会非常的明显显著。那这边举了2个例子。这个例子其实这也是在德国的例子，这是一个50年的老厂。刚刚讲台湾也不过是20年的厂而已。那50年的厂，他们历经了好几次的 revamping。那目前呢，它的蒸汽温压都提升了，同时它也做了前处理，来做释燃和不释燃的一个分选。所以这样的观念其实都是我们可以参酌学习的一个对象。那这个是在奥地利的一个厂，同样的，它也是一个50年的老厂，那也是历经了好几次的外观拉皮，内部在做制程的一个调升和效能的提升。所以呢，从这样来看，其实台湾的环保署相关的政府单位，我们也在推这样子的一个观念。其实环保署现在它要推就是循环经济园区的一个概念，在从北到南有几个地方政府，他们都会有一个循环经济园区观念，把既有的设施做一个整合。那另外呢，就是针对这24座焚化炉，也都要去做它的效能的一个提升，透过刚刚讲的这些海外的这些新的技术，来把整个效能提升。那我这边就讲一个例子，好，这个是台湾从08年到现在，现在还在建当中，在桃园大潭那边的一个生质能处理中心。那这个是一个 BOT 的一个项目，那是由长荣跟CDCI 还有我们合资来参加这样的一个项目，一个得标来执行建造当中。目前在建，预计明年开始试车就商转。那这个厂就有一个特色，它跟整个国际的国际技术相接轨的。怎么讲呢？它这边的能源效率、发电效率它达到28%，如果是能源的回收效率，它达到了刚刚讲的那个算法是76%。远大于刚刚讲到65% 欧盟的一个要求。另外呢，它的因为处理废弃物种类多，所以它有使用的一个水冷式的炉床，然后呢，锅炉的部分也用特殊的一些合金批复来抗腐蚀。那当然，它整个废气系统也都是换代的一个废气处理系统。那同时呢，我们在操作跟管理的话，也都引进了一些智能化的一个设备。那另外更特别是，它整个园区就是刚刚讲的循环的园区的概念。废弃物进来，无论是家户垃圾或者是工业废弃物进来以后，经过合适的分选以后，可回收的当然就回收再使用。那衍生出来这样可作为燃料的，经过焚化以后产生的底渣，也是拿里面也去分选，再去做粒料的一个使用。那没办法处理的飞灰，我们可能会固化在厂内就有一个掩埋场，它也不往外送。那另外呢，厨余的部分，就是有机废弃的部分的话，我们是做一个厌氧消化。那同时产出来的 biogas 事实上是可以再发电用。那里面的藻渣跟藻液也都可以回做一个土壤的一个等于说类似肥料的一个用途。那当然它也产出电力。所以整个这个案子，我等于说我们刚刚有介绍的是说，台湾好不容易经过12年，没有机会这样子一个新案子。那我们希望透过这个案子这个实施，无论在硬体、软体还有概念上面，都能够跟世界最新的这样子的一个 energy from waste 的一个方式做接轨。那最后也介绍一下，做个广告，这个我是中鼎集团，台湾最大的一个工程公司的子公司，Ecof。那我们是第2个品牌，专门就是在做所有这些循环经济、绿能方面的一个投资跟经营方面的工作。谢谢大家。
President Diao, yeah. So now we are to have the session discussion. So please, every speaker sit upstairs to take a seat.
maybe speaker have the microphone here. It's okay.
Now we are open discussion, question and comment. Yeah, please.
那个第一个要问的，我们副座哈，就是这个能源局很不容易啊，但是 please I use the Mandarin，OK，、好不好？那第一个我concern 的就是我们现在，因为我是桃园嘛哈，大潭我也很熟悉，因为我们原来公司是大潭那个工业区的，刚刚我们刁总那边的会员，所以蛮懂得他的荣鼎公司的事情。但是这个问题是 how to control overcome 这个居民的这个抗争啊，这是第一点。第二个就是因为这个我的另外一个 partner 他们投资的一个太阳能电厂，在这个要做关系哈，跟这个这个日本的一个公司，但是呢后来都是因为这个瓦斯啊就不够，那瓦斯的问题又要铺这个管线，要铺到关西去，所以后来也是这无疾而终了。所以我们比较 concern 的是说，这个情况下，这个另外一个就是最重要的就是国家的安全的这个 security 的问题。你这个 natural gas 要进口，进口以后呢，第一个要 terminal 要这个东西，然后呢，这样的情况下是对我们政府来讲是他怎么来考虑这个关键的事情，好不好？这是第一个问题啊，谢谢。第二个问题还要问我们的绿能所了哈，因为 Tesla 我看了很多的资料，他们的这个电池啊都是用1000瓦能够 $1 的这个观念，这个马斯克他特别讲的这个问题。那我们绿能所好像都谈到发展，但没有谈到这个成本，因为我们作为业界都常常考虑的就是你投入多少的经费，投入多少的，我们能 come up 多少的 result， 这个是我们很关心的了，好吧？这个两个问题，谢谢。
谢谢。我先对那个大潭，我们在大潭做接收站哈，其实抗争的不是居民，大部分是环团的哈。那主要是早教的问题。那但是事实上，我们这一个大潭电厂，我们只能这样说，我们是通过环评的。虽然当时环团有不同的意见，或是有强烈表示，但是我们在环评委员会，我们做了多项的沟通，也做了非常多的折中哈。所谓折中，大部分就是花钱去改善。那当然，这个确实是有不同的意见，一直到现在都有哈。不过那意见通常是来自于环团，倒不是附近的居民啦哈，因为附近大家居民，我的理解，反对的主要的都是或者是我们一些公民团体哈。那当然安全的问题是一个问题哈，就是说过去我们的在电力系统，我们的能源组合，我们有核能、有天然气、有煤，好，那比较多样的组合相对会比较稳定，所以我们过去强调所谓能源多元化。那未来我们没有核能之后，我们又减少排碳，那么天然气要提高到50%，事实上对我们的安全是一个挑战，是没有错。所以我刚才才讲，我们要到达那个天然气50%啊，我们对于天然气有3件事情要做，其中有2件，第一个我要供应的安全，好，那我必须在来源多元化，也就是说我天然气的采购量要比以往更分散，好，那这是我们现在在做的。那另外一个就是说，我过去天然气其实是没有法定的安全存量。为什么过去没有法定的安全存量呢？因为过去它不是主要的发电方式啊，而且它的储存成本其实是比较高的。我储煤其实是比较容易、比较便宜，成本也比较低，风险也比较低。那我除天然气，我的成本会比较高，那所以我就要去过去除不多，那我现在就要去大量的储存，所以我要增加接收站，我要增加我的储槽，那我也定了所谓的安全存量哈。那这个是有一点 trade off， 因为我们现在是找不到那个又安全又便宜又干净的能源方式哈，那所以事实上就是说，我如果要在，也就是说减碳或环境，事实上要成本的，大概是这样。那另外那个瓦斯的供应线路是很重要的哈，尤其是它的我刚才讲的 piping system， 这非常困难。好，那坦白讲，就是说你要挖马路，你要埋水管比较容易，你要埋天然气管非常非常困难哈。马路中间挖一条，民众说这是什么管？说这是水管，他会比较安心一点。 大家看到那么粗，你说什么管？如果说瓦斯管，他晕倒了哈。那所以这个现在确实是困难。其实我们现在做能源建设来讲，应该讲非常困难，就是说大家都不喜欢能源，大家都要用，但是大家都希望这个东西呢是邻避设施，是做在别人的地方，包括我们所谓跟环境的绿能、风力发电、太阳光电一样，很多人抗争。所有的抗争的人，我做了好几十年，所有人抗争的人做，我从来不反对绿能，我只是反对你把绿能做在我家附近而已啊。别的地方有更好的地方，请你到别的地方去，但是你不要说我反对绿能哈。那所以这个是困难。那当然这个也不是只有发生在台湾，其实我们很多国际会议里面，全世界都一样的哈。那但是我们就是做能源的嘛，那我只好面对这个问题哈。那么大概是这样，确实很辛苦，也很为难，希望大家多理解，谢谢。
谢谢李副座，好，那我们欢迎李博士。
这个问题是所有做电池的人全部要问的问题啊，又成本又要低，又要好 ，life 又要长。所以呢，虽然我们没有像这个Tesla那么聪明，也不可能赶得上它，但是呢，我觉得我们还好，台湾还没有那个1000公尺。这个目前来说的话，所以我们走的一个方向呢，其实我们就找 long life 的。所以呢，假如说我今天用 LTO 来进行的话，一个非主流的一个材料来说的话，我们把 safety 放在第一位。那成本的部分来说的话，我们在下降中。我们在去年的时候，我们因为材料我们有下降的就是光材料就是原料的部分，我们有下降的80%。那现在还在奋斗中，所以我们在降成本。那这部分来说的话，那 LTO 来说的话呢，刚刚看到 data， 同仁给我的 data， 我一直强调同仁干什么？好像很没有信心，都是1万，就是说 Tesla 来说的话，也许他们到达4000 life cycle。那个在 LTO 的话，就是1万起跳。就与车同寿，所以我们有时候打出来的时候，我就写与车同寿，所以我将走共享，我将走共享，也就是说这讲说 niche market， 就是说也许我就走到另外一个地方，我就不跟 Tesla 来去竞争它的，到大陆去的时候，他们走的那个低价，以及他们那个长距离，那长距离可能就是走到3元啊，然后锡炭啊这些部分来说的话，但是因为非常就是说当你技术要很强的时候，那个 safety， 它是要确定，它越烧越旺啊。我们中油公司一烧就完了，那能源局的长官在这个地方听到我们烧的话，有可能的时候都吓死了。所以这部分来说的话，其实situation 是不一样的。所以我们中油现在目前来说走的方向就是在一个小的一个范围里面，然后适合我们的开发。这个很欢迎后面可以继续讨论。那因为这个是大题目，谢谢。
Okay, because limit times, we last one question. Thank you.
那个我也有一个类似的问题哈，就是说，想请教 CBC。就是说，为什么我们不只做整合就好了？因为大家都知道，太阳能板或者是电池，你可能寿命到了以后，你要处理那些的材料，把它回收等等的，会花很大的功夫。那我们知道，工研院在做那个太阳能板回收，现在也还正在研发当中。那你以后做出来这个电池，你怎么去回收？哈，这个。就说回收上有没有什么困难，或者是这个会碰到哪一些这个问题啊？还有就是说电池制作过程里面，其实污染是很大的。
这也是一个很大的问题。我觉得啦，这是我个人的这个觉得啦，回收就很像太阳板的话，你silicon的回收以及我们电池的回收，其实如果可以厘清它是什么样的材质的时候，是回收的技术是不是问题？所以像我们预备任何东西的回收，像铅回收是铅电池的回收的话非常简单，因为它东西简单，所以我相信到未来等到电池全部都已经。这个2050年的时候起来的时候，那时候一定是全部的时候，你势必一定要做的时候，那时候 technology 一定会到位，因为回收终究比做电池来的简单。那我们讲说这个能不能够去做完这些东西的时候，我相信到 技术到那个地方的时候，大家都会解决。我觉得技术一直不是问题，都是成本的问题。那成本的东西的话，就是在建制的情况之下的话，会继续下降。所以我很高兴在这个地方，我们中油能够进去配合国家的政策，然后相信这个时候不会太晚，因为大家正在发展中。谢谢。
Okay, we are closing this section. Yeah, thank you for all of your attention and thank you all the speakers. Thank you.
谢谢大家，那我们就简单的小小的休息一下5分钟。The final section will in 4:15, 4点15分。
我再跟你讲一个，我知道他的宜兰那边下的挖，每一次挖
谢谢大家。2分钟之后，最后一场研讨会我们要开始。We will begin in 2 minutes. Final section. 因为时间我们希望把它浓缩一点啊，因为今天有稍微 delay 了一下。我们4点15分就开始今天最后一个场次的研讨会。如果方便的话，我们请工作人员帮我们引导来宾，请大家尽速的回到座位当中来。表定我们大概5点钟结束，那么刚才我有稍微 delay 了一下，大概延迟了有15分钟左右，所以这一个部分的这个时间呢，我们稍微缩短，中场休息时间缩短。We will start the final section in 1 minute later. Please have a seat. Thank you. 我们请工作人员帮我们引导所有的来宾进到场子里面来，谢谢。而今天第4场的论坛呢，主题是前瞻能源环保技术。The final section is forward-looking energy, environmental technology. Let's welcome the moderator, Professor 肖树山，欢迎肖老师到台上，欢迎。
Okay, I think this is the last section, and I just asked some professors and who said probably in this section most of attendance is Taiwanese. So I think maybe, but still depends on the speakers. Yeah, but I think maybe it's free to use Mandarin. Maybe it's easier for everyone to understand. 那我想非常感谢大会邀请哈，来负责主持最后一个 section 哈。那同时讲一个题目，不过也很惶恐啊哈。对，因为我接到这个电话，其实有点赶，好像才差不多10天左右啊。那没有太多时间准备哈。那我是拿了我自己的目前
在执行的一个计划来讲那我想，因为我们已经 delay 很多，我就不耽误时间，我们直接到那个 speech 里面那我今天如同我刚才讲说，我今天讲的题目是目前正在执行一个那个科技部的绿能推动计划那我们因为团队有一个很厉害的人在核能研究所所以他很会帮我们计划取题目那我们的这个题目叫做 Biomass Gasification with Supercritical Cycle for Energy Supply System 那这个是符合那个科技部征件，但是它征件里面有一项是希望做生质气化生质污气化，但是它又把那个 supercritical 的 CO2 的超临界的这个系统放进去我们本来是觉得蛮怪的，但为了要 fit 征件，我们就把它放进去，那就变成这样的题目那我们取一些简写的字当然这个是经过设计就叫做 big success 那所以其实我过去好几次到国外包括国内跟大家讲我们做的东西讲完大家都不记得做什么，但是就记得我们有一个 big success 所以大概一定要介绍这个那我是肖树山那我在中央大学机械系跟能源所那目前担任工学院院长，那同时是那个科技部能源学门的召集人那也希望各位先进未来有机会能够多帮助我们学界在能源科技上面的这个技术等等的研发那我想因为时间很短了那前面这个都是比较介绍性的我就把它跳过去那多留一些时间给后面，然后还有包括后面的讨论，那这个其实都是过去的一些 issue 包含减碳等等我想就不花时间在这个上面包含我们一些能源的现况那当我们在做这个我想刚才的几个演讲有提到2025我们要非核嘛那非核其实再生能源就很重要当然我刚才有听到有一些学者也很关心这个，反正能源就是我们一定要用，但是也有很多问题那常常很难所有东西都兼顾这个上面就必须要做取舍那最近当我们在设计上面20%、30%、50%大家都知道，但虽然有一点小的调整那除了这个之外，其实减碳在我记得10年前是一个 big issue 那在台湾在绿推的阶段，好像somehow我们感觉比较冷了一点所以但是最近又变得很重要因为我觉得就国际重视不重视那现在看起来台湾其实面临非常大的减碳的这个压力那这个可能是我们要非常注重的那我想在我介绍我那个 big success 之前我先讲一下这个 magic 那各位知道我们在能源国家型计划有第一个 phase 第二个 phase 那我从第一个 phase 到第二个 phase 都有带一个团队做那时候有 clean coal 或者减碳的一个主轴那在 phase 2的时候，那个主轴叫做净煤减碳那所以我们做的就是以 clean coal 为主那然后用气化的方式，那因为气化的方式它可以比较容易做二氧化碳捕获所以就跟这个 carbon capture 整个连起来那我想那个时候其实跟中钢也有很多合作我们在中钢也办了好几场这个研讨会那后面有跟永丰余跟华指做合作，那我们那时候取的题目叫工业区气化多元应用multiple applications of gasification for industrial complex 所以简称我们叫 magic 这个都是我一定要讲他名字就何所的邱耀平博士他是我学长，就是很能取题目那个林坤松研发长其实也是我们团队很重要的成员之一那这个在我们 Magic 里面的架构了因为那时候是 Clean Coal 所以以 Coal 为主，但是我们也多元进料所以会放一些粉煤去混烧那从这个 Gasification 到它的 Gas Clean Up 然后再到这个 CO2 的捕获然后之后我们这个气合成气可以做 Chemical 也可以做 IGCC 的发电那当然这个是一个蛮复杂的系统，所以其实台电是对这个有点觉得太复杂那希望如果 IGCC 有一天成熟直接引进，所以我们这个部分就是跟台电具体合作比较困难，那曾经跟中钢讨论过 那中央那时候有想说是不是用这样的系统去取代这个高炉哈？对，那我们最后也有跟那个永丰余去合作哦，在华指啊，希望建一个15 mega 的一个释放场域哈。那这个是我们相关的子计划啊。其实我时间已经过一大半了哦。那这个是在 NEP 2的时候的计划哦。那我今天其实主要要讲，刚才有提过这个 Big Success 哦。那当然它是因应科技部绿推计划增建，它所有的要求把它合在一起所做的哦。那这个是我们做的这个 background， 我想今天大家议程很多哈，这个都有讨论过哈，就不仔细讲哦。那当然这个是以 biomass 为出发，因为在新的绿推计划完全不谈煤哈，那也没有减碳的东西在里面啊。不过我觉得这个其实也是一个蛮痛苦的事情啊，这个其实都需要去做研发了哈。对，那但是它在这个 biomass 上面有这个企划的这个部分哦。那那 biomass 当它就可以结合到这个循环经济的部分，因为我们用很多废料那废料去产生这个电力或者能源那它也是一种循环经济的概念那这个地方大概就是我们谈这个计划里面循环经济的概念那我想我主要是要介绍我们的这个计划的架构当然我们第一个我们可以用 biomass 加 coal， 不过我们目前所做的都是只有 biomass 并没有把 coal 摆进去，但多元进料绝对是一个可能那由刚才的题目可以看到我们 gasification 会是一个重点，然后因为 gas 要 clean up 然后这个 supercritical 的 CO2 的发电系统，它主要是有点废热回收啦那再加上微电网跟 AIoT 那现在加个 AIoT 就感觉比较先进所以我们但不是为了先进加 AIoT 那在计划增建，它其实要求我们做一个这个百 kW 级的这个企划的设备那然后废热里面我们要搭配一个10 kW 的 supercritical CO2 的发电系统。那然后我们在计划里面再把这个整个电力进到我们的 microgrid 包含一个储能系统然后它可以送到这个驾户里面去用那这个我们目前考虑的大概就是生质物包含一些废弃物那目前我们整个合作的单位包含中央大学、湖北科大还有中兴大学那然后在法人这边包含核能研究所还有金属中心然后在产业目前有中兴电工跟新环新环是一个 local 做设备企划的一个公司。那中兴电工大概跟我们搭配是在微电网跟那个储能的设备上面所以我们大概在企划这边大概2个部分因为核所有一个100 kW 这个 fixed bed 的 gasifier 所以我们请他做一些这个农林废弃物等等这个料源在这个企划炉里面的一些实验然后去取得一些 data 那在中兴大学的吴耿东教授他主要发展农业废弃物的这个 down-drift 的 gasifier 这 gasifier 其实是简单的但是我们知道其实生质企划说简单，但它其实也蛮复杂，因为它一直实际去用就会产生很多问题，包含它有氯有什么等等结扎啦那甚至这个tar 等等问题那用这个简单的设备去处理，其实我们反而让事情变得简单那这个出来的企划我们就会进到那个涡轮机去发电那对不起，那个合成器会燃烧然后去发电那个废热我们会推动这个10 kW 的 supercritical 的这个 cycle 那再去发一些电那我们整个会进到这个 microgrid 那这个 microgrid 就可以去提供我们的设计，当然是可能是在一个农村，它可以提供40户、50户的这个农村的家用那我们也在想说结合 AIoT 那这个我用这一张讲好了那 AIoT 主要是做气象的预测，还有过去 data 的分析，来决定我现在要发多少电那我去 control 我的 biomass， 我的废弃物要有多少进料那这个是我们的几个子计划那这个就我刚才讲说这个 AIoT 我们去控制的部分我们一则是从气象 预测然后去控制我们整个发电量。当更理想，我们做到第2步，就是我再结合到我里面各个设备的 control 不过现在经费没有办法做到实际的那个 sensor 什么的，因为那个蛮贵的那我们有做一个 app 的这个系统去看这件事情那这个是我们在竹山的一个实验的场域那刚才讲到说这个发电我们就会到那个可稀释的充电区，它就可以进到 microgrid。那里面有很多燃料电，那个不是燃料，那个锂电池那电池我也可以一颗一颗拔着到别的地方去或者附近的地方去做利用那整个整合就会是像这样子我们如果完整的话，可以到这个大概400户的这个家用那当我刚才讲说这个合成器里面有一些粉尘我们也会做除尘的事情这个我们做的一些 study 然后 supercritical 的这个 CO2 发电这里面就蛮多技术了当然我们这个做的比较小型那目前整体做的也还不错那个精工中心应该是台湾第一个在做这样子事情的一个单位那我想时间差不多我们就希望这个大家包含台湾的绿能包含这个循环经济能够 big success 大家一起这个成功了好，那谢谢各位。好，那我们底下请第2位 speaker Dr. 王俊修他是中钢公司那其实之前我说我们跟中钢合作，也跟这个王博有很多这个接触。他今天要讲的题目是太阳光电案场运维技术。
谢谢肖老师的介绍。那大家好，我是王俊修。那我们公司的那个研发人员。那我们所负责的，在我们公司最主要的就是有关于绿能以及一些二氧化碳减碳的相关技术的一些研发的单位。那接下来我跟各位介绍今天我们所一样研究的一个主题，就是有关太阳能电厂一个运维的一个技术。那今天这个简报里面我把它分成4个部分了。首先我会介绍一个我们的太阳能的公司，就是中钢光能。那第2部分我会跟大家说明，就是为什么这个部分运维这个部分对我们中钢公司是相对非常重要的一个工作。那第3部分我会跟大家介绍我们目前手边所做出的一些发展的一些内容。那最后跟各位说明一个简单的一个 short conclusion。OK。中钢光能是我们的一个子公司，它成立在于2016年的时候，然后它主要是一个 JV 的公司，4家公司所投资组成是我们的母公司中钢公司，以及中裕环保，还有中钢碳素以及中龙钢铁。那它主要的业务呢，就是负责我们所有的集团的太阳能的安装，包含 EPC 工作，还有运维或者是管理这些案场的一些相关的一些业务。那在这3年里面，中钢光能其实已经帮我们整个中钢集团建置了83个 megawatt 的这样的一个 capacity。那主要都是全部是分散在我们所有的子公司的屋顶上面，大约60个 megawatt 是装设在我们中钢母公司的主厂里面。这样的一个60 megawatt 的一个大小呢，刚好就是我们全台湾第一个最大单一个案场的一个建置的一些规模。那这些是我们目前建置在我们所有子公司的一个案场的一个照片那我们大概已经可以，我们现在可以发1亿多度电的这样的一个能力，可以减53万吨的一个二氧化碳每年这样的一个 capacity。OK， 那这边我是想跟大家介绍一个算是一个第一 pioneer 的 example。这个图片是在我们中钢的一个大水池那这个大水池它大概有 1.25 的那个公顷的这样的一个面积它是储存大约65万吨，60万吨左右的一个水那它这个水主要是来自于一些再生水，是我们这个 recovered wastewater from 在我们的那个 industry 里面的一些设施使用那这个 1.2 个 megawatt 呢，是一个在全台湾算是一个第1例的一个应用在一个工业的大水池的一个案例那这样子的一个案例其实是一个非常不错，就是去展现说它是一个不止它是可以产生绿能，而且像是一个那个 回收食用水的这样的一个demo。在我们这2-3年的这样的一个运转下面，我们发现这种 floating type 的一个 system， 其实它的 efficiency 是非常的高，它的 PR value 它可以到达90%以上。那我们还有发现一些额外的一些 benefit， 就是说它盖了这个之后，我们发现它的那个水的挥发度相对会低很多，所以其实是可以对一些节水的一些应用。那相对现在水情吃紧这样的一个设施，其实对我们就是帮助相当的大。那这些是它的一些我们建制过程的一些照片。那这样的一个主结构里面的一些 PV 的 module， 我们这边所使用的是一个 bifacial， 是双波的一个 module， 最主要是它是比较可以抗一些 moisture 的一些设计。那这边我们是用一些铝合金的当做一些支架，而它的这个floating body 是用它的full grade 的 HDP 当做它的这个 material。那我们在这个是一些我们整个建制的一个过程它是一个难度相对比较高的一个建制的一个状况。那接下来我们就进入到第二个 section 就是说我要去说明说为什么 OEM 对中钢公司其实非常重要。那根据一些文献的一些报道，其实 PV 如果装置在台湾的这种环境的那些工业的一个环境里面，它的 energy loss 大概 4% 左右。但是我们厂区其实有一些已经运转大约10年那种小的 PV 系统我们发现就是说，其实在一些 worst case， 它的衰退率大概有接近到 60%， 所以是相对高的。所以因为有这样的一个历史的这些资料，我们发现在我们中钢厂区装 PV 太阳能其实是一个很大的挑战，因为它 decay 其实相对是非常的快。所以我们就针对这样，我们就有盘点说我们这样的一个 base 83个 megawatt 的暗场，我们做了一些所谓的暗场分级的工作。那我们发现在我们这种场域里面，其实可以被 full recovery 从下雨可以全部 cover 它的 performance 的话，大概它的 percentage 大概 only 只有 40% 左右。那部分回复或甚至完全没办法回复的，就占了大概 60%。所以说要怎么去维护这样的一个太阳能系统，其实相对变得非常的重要。所以这 issue 对我们来讲是非常重要。所以因为这样，所以我们必须要去做一些更有效率去维护太阳能电厂的一些开发以及一些措施因为我们的太阳能电厂是整个散布在我们中钢集团，而且在屋顶上，维护也相对比较不容易这是等于是比较花费人力的一个维护工作。那这边是我们跟大家说明做我们一些做维护的一个开发的一些逻辑那大概可以分2个大部分。第一个部分就是电脑 monitoring 的一个 section，第二部分就是所谓的 action 的 section。这个部分我就举个例，就是说我们在这个部分是我们会建一个 big data 的系统，然后去收集所有中钢的一些集团的一些 performance 的 data， 然后我们会用预处理一些参数，例如说 PR value 或者是 RI value， 或者一些 performance per kilowatt 这样的一个 value， 以及一些基本的一些 performance 的 data。那我们用这些 data 呢去做互相比对，然后去把一些看起来好像有点问题的这个串列呢把它挑出来。挑出来之后，我们会进到第2个 Level 2的一个解析那这边解析的部分，我们就是利用一个 AI 的一个方式去解析这样的一个问题呢，是属于怎么样一个类型的问题然后把这样的一个 information 丢给我们的工作人员请他可能告诉他这可能是怎么样一个类型的问题，然后请他挑选适合的工具去现场找出实际的问题所以这等于说用这样的一个步骤，其实可以把我们的一些问题整个把它限缩，然后而不是个盲从的去找问题出在哪里所以挑选适当的工具去找出问题，然后解决问题，这个就是我们的 H1 跟 H2 的所要做的动作。那最后的一个结果呢，我们会把它弄成像是一个 data 的一个状态，然后再回传到我们的大系统里面。然后这大系统呢，我们再借由这样的一个大系统数据，可以在 reprogramming training 我们的 AI 的这样的模型。这大概是我们目前一直持续在做的一个工作。那这也是我们的一个逻辑。那接下来就跟大家快速的说明说我们到底做了哪一些工作以及开发。第一个就是我们大系统的部分，大系统部分我们是可以 trace 所有的一些 performance trend 的趋势然后也可以结合一些 大环境的这些数据。那我们利用这些数据呢，我们会做 programming， 然后把它做成一个 model。这个 model 呢，我们会利用这个 model 去预测，太阳能性能应该要怎么样的一个表现。如果有一些差异的话，它就是可能是环境所影响的这样的一个performance loss。这 performance loss 我们如果有了之后，我们大概就可以估得出它的 revenue loss。有 revenue loss， 我们就可以 define 它的必须要清洁的这个时机点是应该怎么样。举个例，就是说，如果这个累积的这个 revenue loss 跟那个清洗的成本是达到一个相同的时候，那其实这个 point 就是一个最好的一个清洁的 point。那我们就会发出一个讯号给我们的工作人员说，那你必须要去清洁这个暗场。所以这大概是我们的一个逻辑。那接下来我们也有发展那个 IR 的一个 detect 的一个方式。那这个方式是 based on IEC 的方式。那我们也撰写一些software 可以去自动的判断这些 IR 图片的 hotspot 的位置在哪里，来减少人力的一些消耗。那我们也做了一个 IV 的 tools， 用 IV 的 tools， 我们可以直接在我们的暗场去测试说这个 PV 的模组的 degradation 的那个 rate 到底是多少。那可以用一些数学逻辑的方式去回推，在 normal condition 的时候应该要有的一些 performance。那另外一个 tool 就是一个模拟的软体，这模拟软体最主要就是帮助我们去理解说，因为我们公司的 dust 有一些比较特别的种类例如含铁的东西那我们去主要是看这些 dust 到底在我们的那个 PV 上到底会有怎么样的一个遮光的一个问题，以及它的形成一个所谓的收油层到底是怎么样的机制用这样的软体，我们可以去预测，就是说它这个性能应该要怎么样的输出，然后它的那个可以用在我们未来的选址上面的应用。然后接下来一个工作就是我们跟一个化工厂合作的一个东西我们跟一个化工厂去合作，去开发一个就是所谓的自洁涂料。那这自洁涂料呢，它其实是有2个 function， 一个就是它具有抗反射的效果，以及它可以自洁的效果，它一个超亲水性的一个function。那它的这个涂在太阳能表面玻璃的时候，它其实可以产生一个亲水性角非常低的一个超亲水的自洁效果，以及它的多孔性可以增加那个抗反射的一个效果。这是目前开发出来的一个进度状态。那我们实际在一个 pilot test 的时候，我们发现说，那确实在应用上它可以减少我们的一些清洗的一些频率，然后它可以去修复我们因为清洁造成 ARC 就 AR coating 在 PV 表面所剥落的一个状态，可以去做一些修复。然后这样子实际在做的时候，看起来它的 performance 可以提高大概 3% 左右。那最后一个就是我们有做一个就是所谓的自动清洁的一些prototype 的一个 system， 因为有一些暗场在屋顶要去维护是非常困难的但是那些暗场有时候可能是只要下了雨它就会恢复了所以这种类似这种暗场的话，就适合做一些自动清水洒水的这样一个设施所以我们这边有先做了一个 prototype 的 system， 所以未来是想说有这些类似的暗场可以用这种去做这个取代人工的一个方法。那我们现在目前这几个月做起来，看起来它那个回复效果大概可以增加2到3% 的一个状态未来我们也会把我们的一些 AI 的一个 model 导到这边做一个更完整的系统。最后这边做个show conclusion， 就是说我们这边完成了全台湾首例的一个浮力式的一个太阳能电池在那个供应的废水应用上。然后我们这样的一个整合式运维技术，其实我们可以把我们这几年来的一些 operating keep 得非常的好，去避免我们一些历史的一些状况。然后我们已经完成了83个 mega 的建制，然后可以减大量的碳。未来我想中钢公司也是会持续追求一些环境的一些 friendly 以及一些 CSR 的这样的一个责任。好的报告在此，谢谢各位。
谢谢。我们底下请第3位 speaker 台电再生能源处李文斌副处长，他讲 Wind Power and the Circular Economy。
各位参与的那个伙伴们我的英文是很烂的啦。但是因为准备是也准备的所以 就因为我的英文也很简单，所以而且都是讲一些概念性的，所以请大家忍耐一下，我还是试试看用英文来报。好，不好意思。Good afternoon, ladies and gentlemen. I'm Li Wenbin. I'm from Taiwan Power Company, and this wind turbine is our wind turbine in the Taichung Harbor, Gaomei wetland, and I would like to introduce something about wind power and the circular economy. And as everybody knows, wind power has been harnessed from 1980, and it grows very rapidly. For example, in the 201 and the 2017, its capacity increased 23 times, and its annual growth rate about 22%. So it reached 651 gigawatt accumulated in the end of the 2019. If we take the 2 megawatt as the average size of the wind turbine, there are about 326,000 units standing on the surface of the Earth, including land and the sea. Its huge dimension look like a very giant as a spatial landmark. In the mountain or the hill, we can look at this view. And at the Denmark coast, we can see different era of the wind turbine. The small one is the older, and the new one is much higher. And also on the surface of the sea, we can look at this kind. And the distribution happened also in Taiwan. Up to now, there has been 384 units of the wind turbine with total capacity of the 857 megawatt, with a high density of the 23.8 kilowatt per kilometer square. This density can rank Taiwan into the top 20. So the density is rather high. And the location of the Taipower, the wind turbine, is as shown. Of course, we have other private wind turbine, but the location is about the same. Although wind turbine emit no carbon dioxide in the operation stage, but it is not free of the greenhouse gases still in its life cycle, especially during construction. And also after commission, the wind farm may become a graveyard of the wind turbine, as the view in the USA, California. So we will check the materials of the main component of the wind turbine, and we can divide it up roughly of the wind turbine. It's the tower, the blade, nacelle, and the footing. The footing, we usually reinforce concrete and pipe. And the nacelle, we have the pressed cover, with plastic cover, but also the metal machine. And after the commission, the steel goes into iron recycle. A concrete welded into gravel and sand, while plastic become a long-lived monster. And what can we do with the blade after decommission? According to Wind Europe, that wind power in average it consumed 10 kilograms per kilowatt of the blade materials, and it is estimated there will be 500,000 tons of the plastic during will be discarded by 2020. And the blade is very long and very huge. And currently, the blade are made of the thermal composite materials. And because of the high cost of the cracking, the ratio of the recycling is quite low. However, the research has turned to the thermoplastic materials for easy recycling. 这个就是热固型的塑胶，这个是热塑型的塑胶，这个它的处理的裂解的那个成本不一样，And we all come to the renewal of the wind power station. The first unit in Zhongtun, Penghu, has operated for 20 years next year. Moreover, 70% of the unit in Taiwan are built by 2011. So their renewable will be proceeded in batches. Now we have a question. How can we fulfill the renewal without producing a large amount of garbage? And we are answered this. It is the purpose of this meeting. The circular economy will help. And some major are shown in following. And like one, we extended the service period by fixing or replacing the bad parts. And two, relocation of the second-hand unit and reuse. Well, I know a case. Second-hand unit after wind turbine after it decommissioned in Germany and has been moved to the West Africa and Gambia for a village to use by the charity group. And we can also store for the spare part or arrange it for the training or the showcase. And also we can expropriate the recovery deposit to encourage recycling. And we have the offshore wind power. How about the offshore wind power? Because the difficulty of the marine environment, offshore wind power, it follows some concept of the circular economy. Likewise, the one, design the service life beyond the 25 years. Commonly, in the land-based wind turbine, we designed the operating period is only 20 years. So the offshore wind are much longer. And also, we prefer the larger unit capacity to decrease the number of units. And also, National Property Administration explored decommission deposit, 4,000 New Taiwan dollars per kilowatt. And also, after decommission, the apparatus above the water surface will be removed. And the structure beneath the water will remain for the conservation of the fishery resources. And also, we have the floating type. We pessimistically too much steel used for fixed and underwater foundation. For a unit, we use the steel for its underwater foundation is about 1,000 to 1,050 50 ton of the steel. By optimistically, the use of floating has been experimented and demonstrated in several countries. So you will use the very less steel. This is my simple conclusion. Well, wind energy is good. Integrating with the circular energy makes it better. And some of my friends, Karen Su from the British office in Taiwan, he said, so green energy and the circular economy can go hand in hand together to make a better world. Thank you for your attention.
Thank you. 我们底下2位都是产业界哈，那底下我们请奇汉科技高金磊总经理。
Good afternoon, ladies and gentlemen. My name is Jack Li Gao. My company is Chihan Technology. I'm a general manager. All the speaker always is a big issue, but it's a very small company. I just focus in my company the solution. The company issue is our solution, the motivation. So today's I discussed the recovery of the waste gas and solvent from the TFT-LCD, the process. I'm not only in the TFT-LCD, we offer our customer the solution, even the lead battery or the like the polyamide thing, the process. I always this is a presentation outlines. We'll talk about the TFT-LCD array process. The next is photo risk stripper introduction and conventional stripper recovery system. Today's only one the TFT-LCD our customer. For example, now stripper we offer our solution the retrofit. This is the system, and we discuss the final. We discuss the benefit. With the rigorous the development of the personal computer, the notebook computer, digital camera, and the liquid crystal panel, smart mobile phone, and the tablets, the computer, the high-tech industry has driven the growth of the interrelated industry. With the development trend of the green and the environmental production in the world industry, the number of the newly building the semiconductor 12-inch fab all continue to increase, like the TSMC. Next year we are to the American Arizona to building a new fab. And the TFT-LCD, the large size panel, the fab, the 7, the 9, or 10, the generation fab productivity have continues. And LCD, especially this year, the Apple Watch, use the mini LED. So LED, the factory, I think that you will have continued to expand. And the vertical and the horizontal integration of solar cell factory, so has never stopped. It's provide that the world economic is undergoing transformation and the change. This is a TFT-LCD array process. This is a glass substrate, clean film disposition, photo risk coating, exposure, developing agent, and the photo risk stripping, and the TFT substrate. Today's our topic is the stripper. The photo risk stripping, he have a waste stripper. Photo risk introduction. This is a main components of the photo risk, like the MEA, the BDG, or DMSO, and the LMP, which are the sulfur amide the high boiling point compound. It is a boiling point almost higher than 170 centigrade. It is a substance with low calorific value it has odor, and it's not easy by decompose. So you can look, its boiling point always very high. So this is about 20,000 years. The most customer the process the stripper Western stripper is a treatment in the process. This is a stripper tank, the fresh stripper, and he delivered to the stripper machine and exhaust. This is exhaust. It goes to the stripper condenser, recovery the waste solvent, and the final to the waste scrubber. The where the stripper disposal from here to the waste stripper disposal tank. Any stripper condenser waste recovery the waste stripper the disposal always to this tank, and the other to the the other COD, the organic COD to the wastewater treatment plant. So this is waste stripping disposal. Maybe I think it's 20 years ago. I think the AO is first introduced the Japanese technology to the Taiwan to the stripper the purification system. So almost his recovery rate over 82%. So every day we added 80% fresh stripper to the system. About 10 years ago, our company developed a new technology. It's a deep filtration system. We make the stripper behind it. We make a new installation the deep filtration system. And look, it's everywhere no change. But according to the field experience, we increased the recovery rate from the 82% to the 91%. And here's the total fresh air added to 9%. Look, it's conventional is 80%. And this is our new retrofit performance is 9%, reduce 9% of fresh stripper. But you know how many benefit? This is our this one is effective correction the amount. This is total recovery correction of burden. But this is a real line. This is before, this is after the filtration installation. This is our I think this is actually from the customer we behind. So look, it's 1,636 liter per day. After installation is 3,767 liter per day. And effects his meaning is through the stripper purification system, he can recovery to the fresh solvent. So this is the total area in the infection is 1,145 liter per day. And then after the deep filtration system installation is increased to the 3,202 liter per day. This is amount. This is amount only. This is the daily total correction amount only come from the exhaust stripper loss. Just the exhaust stripper loss is very big. This is our counting his benefit. This is the cost down amount of stripper reduction. It's one years. It's over $2 million US dollar. Only one FAPE. It's the exhaust stripper loss. We create over $2 million US dollar per year. and this is the cost. So his investor recovered just only 0.369 a year, so it's very short. So I think this is maybe it's a circulation economic impact is big, but for our company, this is our study work, and we keep going to develop the new technology to support customer issue to solution. Thank you. This is our presentation. Thank you.
Okay, we welcome the last speaker, 捷鼎科技杜文强执行长。
First, I should thank the Professor Wang giving the opportunity to hear. Okay. Good afternoon, everyone. Thanks for being here. My name is Robert Du. I'm from the AEC companies. Today, I'm focused for our new developed systems. There's the systems usually in our industrial factories. We use the active carbon to do the absorption. But if you want to do desorptions, you need to replace the active carbon ASAP because the EPA norms regulations very strict. So today's outlines will be four for instruction, preface, content, and conclusion. Here's the charts. Usually in the factories, their exhaust gas will come from these two sides. There's two tanks for the active carbon, one for each one have a fulfill the active carbons. But now our systems, we are integrated from the active carbon, and here's the catalyst oven for the carbon desorption. This is the two pictures to show this is the old type of carbon. For example, Chinese steel, they have a 中国碳素, they come out for this kind of active carbon. But now we are developing a new one. It is the honeycombs type. Because the honeycomb types we install to our systems, we can recover each day or a period of time. So very easy and very convenient for our systems. So processing flow. I just showed the pictures, the flow charts, because now a lot of chemical company or chemical factory, they come out a lot of VOC or all those, but they use the old type. So they need to replace very soon because the government and the EPA ask them, you need to replace as soon as possible. So now they are faced with challenges, but they need to replace each one. For example, usually take 1 week, you need to replace your active carbon. But now our systems, we don't need to do that because we are integrated desorption, absorption, and desorption in the one unit. Here is you can see, this is the catalytic oven. We installed, this is a 2 tank. We have fuel the active carbon. 1 spare, 1 use. After 1 saturate, then we automatically dissolve the VOC by our systems. So we integrate the absorption and the desorption system in the one unit. So there is a very popular in our industrial area. Now they face the problem is they need to change the active carbon very soon in the very short period of times. Now we did the change. We developed a new concept, new process. We build this one in a lot of the chemical factory. So, we designed the systems based on how their exhaust the flue gas or odor. So we needed to calculate and balance all how big the tank, how big amount for this active carbon. And you also designed this is a catalytic oven. So now it is very popular and very cost effective. This is our systems. We already installed one companies. You can, the exhaust gas will come out. Here have two tanks. After one saturate, and we'll automatically replace and automatically change to another one. And automatically it stops the VOC from our active carbon. Here is the company is a stock company. You can see a lot of weight scrubber and active carbon in above their buildings. Still the same efficiency and the same penalty by the EPA because they use the old type, this kind web scrubber system. Here's I took some pictures here. Let everybody knows now all factories in our industrial zone, they have the same problem, all face the challenge by the EPA. Here is I showed the pictures. Here is the old type active carbon. They fill in the active carbon in. They need to replace by the bottom have a leak hole. So very difficult to do the replacement. And now we change to the new one, only one set. So very convenient, very cost effective, and solve their problem. Now, my conclusion is very simple. Here is that we open the door to commercialization. We have a successful development process and catalyst oven which produce industrial integrated active carbon and desorption and the absorption and desorption in the one united system, one unit system, and reduce replacement active carbon from our system. So now we have a lot of opportunity, a lot of markets for the coming futures. So usually here, I put 30 days for the demand by the EPA. Ask the client to change their active carbon. But our system can endure almost 1 year. You don't need to change the active carbon because there's automatic absorption, desorption. Offer more than 40% energy and cost saving because only 1% automatically you can turn on the control panel and automatically to treat the factory's flue gas or VOC. So all the system, our system we design follow the health, safety, and emission norms, regulations. So I think this is innovation and circular energy and circular economy. Thank you. This is my simply, briefly introduce my system. Thank you very much.
So I think in this section we are pretty on time, though for the whole schedule we run up about 15 minutes. Yeah, but I think we can still have some time for discussion. 我们还是可以做一些简单讨论。那不知道在座有没有什么问题要请教刚才的几位演讲者？
大家好好学诱人啊，请问一下，就是如果有朝一日这些未来的能源实现是大同世界可期，那万一就是有生锈的问题就是机电设备如何去就鼎力相助这样？谢谢。就是如果说它在海边，它受那个潮湿啊，还是山风啊，就是怎么去处理那个？对，或是那个就是钢铁的方面，它还是有没有更好的材料？就是如果说用陶瓷还是哪一方面的材料？
如果是有关于那个在海边呢，或者在那个离岸风电上面那个生锈尤其因为我们用到钢嘛，钢的那个生锈是非常重视的，所以这一部分其实国外也都有很好的规范来做这个防锈的这些处理。那当然在台湾这个情况，它潮湿又高温这个情况会更严重，但是我相信这个是可以克服的啦，因为在我们国内和国外大家都投入很多研究在这方面我相信是可以克服的。谢谢。
我想
帮忙补充一下，对不起我帮忙补充刚刚的问题其实我们现在做钢材的那个防锈在台湾主要是以镀锌为主。那现在有很多新的镀锌的技术，它是每年消耗多少的，所以它只要厚度是够的，那它其实你现在看到台湾的台电的电塔，以前都是热浸镀锌热浸会变形，所以现在都是冷镀锌。像我们公司做的产品不一定都是用不需要 stainless steel。其实很多国外的老外来台湾都认为说，为什么台湾那么喜欢用 stainless steel？ 他们认为那是非常 energy consumption 的东西，就是高耗能的产品。那其实现在已经有很多冷镀锌的东西，像我们公司的产品就是用冷镀锌，而且它可以耐到300度、600度，其实都没有问题的。那主要的目前的冷镀锌，台湾也有些厂在做，那我们目前用的还是以日本为主，它的冷镀锌的技术其实非常好，非常的好。
我想问一下中钢的刚刚那个太阳能板的，因为一般我们买太阳能板，它不就是20年后还保证效率有80%嘛？那今天我们掉到60或60以下那按照你们的这个研究，就是最后清洗是洗出什么东西？就不然效率怎么会掉到这么低？那这是第一个问题。那第二个就是说，刚刚听到最后一个就是活性炭的，那改成蜂巢以后那确实我觉得更换确实是非常方便，但是就是说你等于是吸附跟再生一起的话，那我们什么时候才需要更换活性炭？
那就由我来先回答第一个太阳能的问题。那个之前我们那个比较旧的暗场，事实上它那个是比较缺乏维护的，因为那个暗场的维护的频率是参照一些外面的一些维护的一些频率，那大概可能1年顶多1次或2次。那我们在那个它其实在那个暗场上，它一些 一些落程会相对比外面大很多。那如果在那个一些比较不常去清洗的时候，它其实落程会结块。那你在最后你在洗的时候，事实上你并没有办法很完整的可以把那个玻璃洗得很干净，因为碍于就说其实我们不能用一些清洗剂，我们只能用一些清水，所以你没办法把那个玻璃表面洗得非常的干净。这个是它最主要造成它衰退率会这么大的一个主因所以是因为这样，所以我们其实就针对一些到底什么时候该去清洗，来避免这些问题发生所以最主要是我们这样的研究的一些方向。这样补充。
刚刚的问题非常好就是也是现在我们这个在 promote 我们的 market 的时候这个问题以我们现在的经验，因为我们有设备都已经卖出去嘛以它300 ppm 的这个浓度来算的话呢，那它现在每天做8小时的话呢，我们的平均下来呢，我们的设备的活性炭的 regenerate 再生的话，大概用3年才需要更换。如果它24小时的话呢，我们需要1年的时间再更换这个活性炭，所以它非常有效率。还有最重要在这里也跟各位分享，就是说，因为它不需要换。台湾现在的问题是换这个槽要卸下来，卸下来以后再由这个卖这个活性炭的人要再把它带走，再用，因为都每次都活性炭槽都装得很高嘛，所以都要吊车吊上去，再人再装下去，所以非常花功夫，也非常花钱。而且现在活性炭，我想中钢的代表在这吧，我们的了解1公斤都要100块钱。那换一次的话，10吨的话，大概100万，所以1个月换一次，你看看，就1000多万那我们的系统装上去以后，除了 initial cost 比现在的贵一点以外，其他都没有换的事情，因为它自己的会调试，自己会我们的 PLC 会控制，它浓度到了，它就换槽，又可以换这个系统，所以说是非常方便。所以我认为。刚刚我们讲了那个成本的节省跟人员的操作节省，所以达到这个循环经济跟所谓的计划经济或者绿能经济，大概可以降低了40% 的它的这个 cost， 所以我认为是一个蛮好的设备。所以也谢谢我们理事长给我机会在这里分享，好吧？也谢谢你的问题，谢谢。
我想请教一下台电再生能源处那个李副处长台电在离岸风电那个第1期，就是由日本日立的那个风机，它好像最近应该明年就会完工了嘛。那第2期大概也有部分也会施工，在2025年之前。我比较有兴趣是说，台电对于第3阶段区块开发。会不会投入会不会在那个离岸那浮动式基础的离岸风电那边会等于是做台湾的一个 leader 这样 ？OK， 谢谢。
台电的那个离岸第1期现在有2只风机已经架起来了，但是还要等那个线路都拉起来，因为现在是海象非常恶劣的，所以我们的工程当然还在努力啦。那剩余的机组就是总共21部嘛还有剩余的19部，就是明年大概春天那个整个海面上海象比较稳定的时候，还是会把它完成。如果应该可以的话，还是当然明年可能9月都能够并联上来这样。那第2期的话，现在只是在做，因为之前绝标，然后厂商在做那个就是它有产业关联的一些要求，因为要求要在地化，所以厂商还在努力这一块。那另外我们还要做那个现场的地质钻探，所以现在算是属于筹备还有设计这个阶段。那将来是2025年要全部完成。那第3阶段那个区块开发，我们台电一定会参与的啦。那个当然。那需要经过一些竞争嘛，因为它将来可能有一些竞标的动作。那有机会我们还是会考虑那个在水比较深的地方，如果比如说超过50公尺水深的话，那个浮动式的这种基础应该会再拿出来检讨，然后看看有没有机会用。因为也许到了2030年，那个浮式的基础会很有竞争性。我想。 台电在这边是不会缺席的。谢谢。
这个时间差不多了哈，我们可能这个 section 就在这里结束。我们最后有闭幕嘛？那个理事长要那我们谢谢几位 speaker。
非常感谢大家一直跟着我们到现在哈。那今天我再次感谢我们邀请的讲者哈，非常有资料啦，科技的资料给我们，让我们有交换的机会。然后另外，我就是感谢那个巴杰公司的高层这些帮忙让我们有机会跟国外直接连结另外我还要再感谢那个巴杰公司的丁小姐所领导这些公司人员她协助我们把这些办得很好我非常感谢这个真是非常服务的非常周到包括他午餐的我觉得很好吃谢谢谢谢他们谢谢但是谢谢大家希望明年我们再有一次再办一次这样的活动，谢谢还有谢谢那个思怡先生，谢谢。
Yesterday, found myself in the city near Piccadilly. Don't really know how I got here. I got some pictures on my phone.